Hello guys, welcome to my channel, and let us look at this KZN September 2024 as requested by one of you guys. Unfortunately, the paper that I have here is incomplete, and the paper that someone sent me on my email, unfortunately I could not download it for some reason, so it didn't work out. So in my attempts to try and download it, it disappeared. So sorry for that guys, but anyway, let's do with what we have and see what we can achieve. So of course guys, these instructions don't need a second invitation. They need to be looked for and understood, and obviously the rest of the instructions. Okay, now guys, question 1 is the most boring one because it poses no challenge whatsoever. These are just free marks from the examiners to the students, because there's no way students can fail this section if they do their work. Now, question 1 says, the Human Resource Department of a company in KwaZulu-Natal wants to create a model to be used in determining the monthly salaries of its employees. 12, so always pay attention to certain specified numbers. 12 of their current employees were surveyed, and the information is displayed in the table below. And we can appreciate we've got bi-variate data. So once we see that, we already run into our calculator and know there's going to be some least squares regression things coming. So we go to mode, then we choose option 3 stat, then we choose option 2, which is a plus bx. We want that table, that bi-variate table. So obviously for x, we've got 26 equal 1 equal 3 equal 5 equal 6 equals 10 equal 14 equal 12 equal 33 equal 20 equal then 8 equal. So we've got 12 entries here, but why do I have 11? Is there something missing? 6 is repeated twice. Lovely stuff. So be careful guys, so easy to miss this. It's so easy to miss this. So let's see now, what entries do I have? I still don't have. Okay, let me start over. Looks like I messed up. So unfortunately folks, sometimes the going goes a bit nasty. So this one is just labor intensive, otherwise it's the easiest section, but it needs you to stay focused to not make a mistake. Okay, 5 6 6 10 14 12 33 20 and 8. So I've got 12 entries. So be meticulous folks, don't be too complacent, because this section is fairly easy. There's no need to mess it up. So we start with 20 9 10,5 11 10 12 16 15 12 23 18 9. So I've got 12 entries. So we hit our AC button to store our data. Now we are ready. Let's look at the questions so that we can answer them as we go along. We are told here at 1.1 to calculate the mean monthly salaries of these 12 employees, rounded off to the nearest rand. But pay attention guys, this is thousands of rands. So that means whatever value we get, we must multiply by 1000. All right, not a problem. So this is 1.1, 1.1.1. Now the mean here, we just want the y bar because the salaries are on the y. So we want y bar. So we just go to our data and say shift, press 1, This time you're not going to choose a regression. You go to variance, which is option 4. Now there we look for y bar, which is option 5, and then we press equal. And what do we have here? Now, this is very important to avoid rounding off here. This is not the final answer. So this is 13,791,666,67. We can say therefore mean salary is going to be equal to this value, 13,791,666,7 times 1,000. Okay, so this is going to be in rands, so just multiply that by 1 square. So I'm getting 790. This time we choose the nearest is going to be 92 rands. Okay, so we round off in the final answer. Be very careful, guys. All right, so 1.1.2, we need to find the standard deviation of the monthly salaries of the 12 employees. Again, we go to shift, option 1. Again, we go for the variance, and then we want the standard deviation in terms of y. So that's option 6 here, and then it gives us the answer there. So here what we want is this small letter standard deviation of y. This gives us 4,403,87298. Okay, you can say therefore the standard deviation of salaries is going to be equal to what is the stories now? What is the stories? Is this number there? Multiplied by 1,000. So we just multiply that by 1 square. Then it gives us a 4,400 and how many? Now to the nearest is going to be 4. Okay, that's nice and easy. Very easy stuff. Obviously, guys, getting this dude is a mark in the final answer again here, but obviously we're just getting 1 mark here. There were 2 marks there on offer. So this is very easy, not a problem. So 1.2. We are asked a question, how many of the 12 employees earn a monthly salary that is more than 1 standard deviation above the mean? So all we want is 1 standard deviation above mean is going to be the mean plus the standard deviation. Okay, so this is 13,792 plus 4,404. Now what is that? So 13,792 plus 4,404 rands. It gives us 18,196 rands. Now all we want, remember we want above, so we want a salary that is greater than this value, essentially. So how many people are earning that? 23,000 is greater than that. We can't choose 18 because it's less than that. And 20,000 is greater than that. So there's only 2 people. So we can say therefore there are only 2 employees. That earn more than 1 standard deviation above mean. Nice. Just learn to answer fully, guys. Do not be hooligans. Just present your work properly so that someone who's marking you doesn't get tired of you and end up sabotaging you somehow, because that is also possible. All right, great. So how many marks here? 2 marks. So obviously, guys, all we needed to do was to get that mark and the second mark. Nice and easy. 1.3 says we need to determine the equation of the least squares regression line. You see, we already prepared ourselves. So all we need is to find A and find B. So we go to shift, stat. This time we choose option 5, which is a regression. And we choose 1 for A. Gives us our 8,45 to 2 decimal places. We repeat the procedure. Shift 1, option 5 regression, and then we choose option 2 for B. This is 0,45. Okay, great. So after this, we then write our equation. Y accent is essentially 8,45 plus 0,45. This one, we don't need to present it in thousands of things, okay? We can just leave it as it is. It's just an equation. Oh, sorry, there's x here. Okay, great. So we get a mark for each one of those 3 items. 1.4, we are told to calculate the correlation coefficient. Again, this is easy. Shift, stat, which is 1. We go to regression. We choose option 3, which is R. So all we just write R is 0,94. Okay, so easy 1 mark there. Can you see this was a gift from the gods? Now predict what monthly salary will be of an employee who has been working for this company for 30 years. Now the question is 30 years within the domain? Now let's have a look. What's our minimum number of years? It's 1. What's our maximum? It's 33. So 30 is within the domain. So whenever we predict within the domain, that is usually accurate. Okay, but what strengthens that accuracy is the correlation coefficient, and we can see this is a very strong positive correlation coefficient. So this is likely to be an accurate value. So we just write what we know. And then here we're going to have essentially 30. Okay, and don't forget that we will have to still multiply by 1,000 whatever we get. So 0,45 times 30 plus 8,45 gives us 21,95 times 1,000. Therefore the salary is going to be this one multiplied by 1,000. So it's going to be 21,950 rands. Okay, so that's it. We leave it at that. We don't complicate it. So the most important is substitution and the answer. So that's it. Easy 2 marks. Now the last question says, is the prediction that is made in 1.5 likely to be reliable, and give a reason for your answer. So the important thing to say here is that definitely it is. We can say yes. Why? We can say here the prediction is effectively an interpolation where there is a very strong positive correlation between variables. Okay, where there is a strong, I don't know, sometimes I write well, sometimes I don't. There is a very strong positive correlation between variables. Okay, my writing just doesn't want to go well, so that's it, guys. Anyway, it's fairly easy, so you get a mark for our lovely yes and our statements. Obviously, remember, an interpolation, this is predicting within the domain, but that has to be coupled by a strong positive correlation. So those two work hand in hand, because when there's a poor correlation, irrespective of whether we are predicting within the domain, it's unlikely to be quite good. But at least in that framework, we could say it could be reliable in that framework, but technically not quite a good correlation. All right, so this is it, guys. Easy stuff here. We're scoring yabona ngivele yenza into endingazazi lewe funa ndihlanyise kezenza izinto endingayithumanga qhela kabi. So now this is essentially 13 marks, guys, that are a gift from the gods, because there's no working hard there. It's just calculator work stuff. Sometimes I feel this is boring. I should not even waste my time answering these questions. But hey, for completeness sakes, because this paper is already incomplete, might as well do as much of what is here. Now, question 2 says the cumulative frequency graph, which is the ogive, drawn below, shows the ages of the people. So what is it? Ages of the people who voted in the local government elections at one voting station. Use the graph to answer the questions that follow. Great. Now, when we look at our ogive, first of all, analyze this thing. Usually, the last plot gives us the total number of participants that took part in this. Now, if we just read that back on our cumulative frequency there, I don't know why this is not a straight line here. It's definitely not. So if we read that back, that gives us 5,500 people. So always be on the lookout for that. 2, we want the steepest gradient here. So now we can see there's 2 areas of steep gradients. Is this one and that one. So please take a bit of time to get into the understanding, and then there's that gradient. So it could be the same gradient, they could be different, but we want the steepest. Why? Because that would give us the modal class of this, analysis. Now let's have a look. If we look across here, we just know gradient is change in y over change in x, isn't it? Yes, of course. So this is what we look for. And obviously this one is a change in x. Sorry, change in y over change in x. Sorry. I'm already misleading you guys. So don't worry about the change of sign, of colors there. It's not a big deal. Now let's look on the horizontal. It's 1, 2, 3, 4, 5. Again, here it's 1, 2, 3, 4, 5. So the x are the same, right? So this is 5, 5. But now on the vertical, what is this? This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So this is 13. This one is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Can you see this one is longer? So that ratio is going to be 15 over 5, whereas this one is 13 over 5. And you can clearly see 15 over 5 is bigger than 13 over 5, right? So this means this is the steepest gradient. And that would mean the modal class of our data is that gradient there. So please, these things must not be missed, guys. Very easy stuff to find out, but one needs to understand how to look for them. So if at all one asks, what is the model class? It is here. Okay, so that would be from that x value to that x value. All right, now let's have a look. What is the questions? Oh, by the way, we need to understand the scaling factor. Can you see this is 1, 2, 3, 4, 5. So a single digit, a single tick here of the small ones represents 1 unit. But now on the vertical, we see 500. So this is 1, 2, 3, 4, 5. So when you divide that, it means a single little tick here represents 100. This is very important. Take a bit of time, guys. Assimilate the information given. Make sure you understand it without looking elsewhere. Don't look at the questions. Don't waste your time. The last thing you want is to go looking for answers in the provided information when you have not read it to understanding. Understand it first. There's no harm here. You're not going to lose time, believe me. Just look at it, understand, at least you will see you will have answered half of the questions you need to deal with. Now let's start answering. How many people voted? Can you see? Analysis already uncovered that. So now it's more of just transcribing. So this is 5,500 people. Done. Easy one mark. 2.2 says determine the interquartile range. Now the interquartile range, it means we need the first quarter of the total, right? And then that would give us Q1. Okay, and then Q3 is going to be 3/4 of the total. Can you see? And that would give us what we need. So obviously we know that our IQR is going to be Q3 minus Q1. Okay, let's have a look. What is a quarter of 5,500? So just do it on the calculator. Obviously, make sure the mode is correct. A quarter is 0.25, right? Times 5,500. But on the stats mode, this can hurt. So this is 1,375. Now there is 1,000. There is 1,000. So this is 1, 2, 1, 2, 3. So just above 3. But make sure, guys, you are using your ruler here. It's easy for this to go wrong. And make sure there's an intersection, a clear intersection with the ogive. Okay. And then we take that down. You can see that as we take that down, it's almost on that line there. So this is 25, this is 26, 27, maybe around 28 point some change, maybe 29. I mean, it doesn't really matter how we look at it. This is almost 29, maybe 28 comma something, close to 29, so maybe 28.8. It's not a big deal. So we can just round off to 29. So this is going to be our Q1. Then we look for Q3. Now Q3 is going to be 3/4. Now what is 3/4? It's 0.75, right? Because that's 75%. Then we multiply by the total. It gives us 4,175. So there's 4,175 is going to be somewhere in between these ones. Again, use a ruler. And try to be as meticulous as possible. So this one is trying to sabotage me by not intersecting our lovely thing. So if we take this one down, obviously, guys, you're gonna use a ruler there. So we can see here that, well, this is 35, 36, 37, 38. So this is our Q3. So this is really 38.5 or whatever. So it doesn't really matter. So what did we say was this one? This one was 25, 26, 27, 28, maybe comma 8. We can just say this is 28. No, this one was 28, comma 8 perhaps. And then maybe 5. I'm not sure about this one. Let's just have a look, guys. We need to make sure whatever we do is not... My hand is... We can say roughly comma 5, just so that we don't make it too bad. So, and then we're saying this one is 35, 36, 37, 38.5. Okay. So that is roughly what we have. So we're saying 38.5 minus 28.5. That gives us a difference of 10. Obviously, it's not really accurate, but that's it. So this is 10 people. All right. No, is it 10 people? It says the ages. It's 10 years. So that means these people differ by 10 years, okay? Because this is ages, IQR of ages. So be very careful of what is the unit of measurement. Again, guys, this is nothing really strange. A math student already knows how to do this. This one was a little bit tricky, but obviously one needs to know how to do these calculations, okay? This is nothing but easy stuff. So we get a mark for those two because we had to find them and then eventually do the things. Easy, 3 marks. Now the question says, what percentage of voters was 25 years or younger? Now we just go to the age. We just need to go to the age of 25 and then we take it to the ogive. So 25 goes up. This thing has a tendency to really mess with me today. So can you see that we must make sure we intersect our ogive, but yeah, I don't know, my thing is just doing its own things and then it's just before that line. Okay, so what do we see there? This is 5, 6, almost 7. So we can just say that's 700 roughly, or say 680, but let's just say 700. Not a big deal. So this is going to be 2.3. So we can just say the percentage of people, of voters, is going to be the cumulative frequency number, which is going to be 700, divided by the total, which was 5,500. We multiply that by 100%. So we have 700 divided by 5,500, multiply that by 100. It gives us a 12.73% to 2 decimal places. Okay. Now remember, with questions like 2.2 and 2.3, there's usually a range of answers that you would get. So just pay attention to that, and of course try your best to be as close to those answers as you can. Sometimes I find these questions ridiculous because for accuracy purposes it's a nightmare, honestly. Now to give a range that is too tight, it's a bit unfair, but who cares? Examiners are examiners. Maybe there are some rules you guys get taught that this is how you estimate, but an estimate by just looking with your eyes cannot translate to the same thing that another person is seeing. So I feel like if they're going to give a range, it has to be a wide range rather than a narrow range, because truly speaking, it has to be really ridiculous for one to predict outside a given range, you know. But if it's a tight range, it's very easy to just be slightly over the range, and that means that person loses a mark. Really? Ridiculous. But hey, your exams, guys, are your exams, they're not mine. So do what you have to do. Leave me alone, please. So obviously predicting that 700, which is the cumulative frequency, we need it, and we calculate standard style. So we have those 2 marks. An easy 6 marks here. A gift again from the gods. You can see here, this is just to boost the confidence of a student and say, look, for you participating in these exams, this is a bonus mark for you because we're opening up with smiles for you. That's if, of course, you know your work. If you don't, it's going to end in tears, right? So let's try, guys, to move as fast as we can. Now, we have question 3 here, analytical, grade 11 stuff, usually. Now we have a parallelogram, A, B, C, D. We can see it with coordinates of A shown, coordinates of B shown, coordinates of C, that's a question mark already. That's a potential question. And then D, also given, right, are shown below. AC is drawn. Now what does AC become? A diagonal. We can then use another diagonal. Say, look, we know a very special property of the diagonals of a palm. They bisect each other at a common point. So this means this point here would be the point of intersection, so that we have this equaling that, that equaling that. So do not wait, guys, for this. And as you can see, the y value of B is less than the y value of D. So that means this is not a horizontal line. Okay, good. So that means we need to expect a y value here that is between -1 and -2. Great. So this is very helpful. And obviously with a palm, the opposite sides are parallel and equal to each other. And they are parallel and equal to each other. Okay, that is very important also. Okay, all right. Now let's leave it there. Sometimes you don't want to overly do things so that you don't mess the diagram up. Now we're told F, G, and H. F, G, and H are the x-intercepts of AB, AC, and AD respectively, and we can see that. Now E is the point on the x-axis to the left of F, there it is, and J is a point on the x-axis to the right of H. That's also okay. Right, so now that we have this, what can we do with this diagram? Obviously, we've got 2 points on AB. We can find the gradient. We can also find the equation. The equation will give us the x-intercept at F, the y-intercept at A. It's already 4, so there's not even a need to look for it. And from the gradient, we can work out the angle of inclination. This one, we don't have 2 points, but what can we do about it? We can actually find the gradient of AD. Since these are parallel lines, it will be the same as the gradient of BC. Use B to find the equation. That's about what we can do. And we can do the same for AD. Gradient, equation, we work out the x-intercept. We already have the y-intercept. Then what about DC? We can do the same. Find the gradient of AB and transfer it here because these are parallel lines. Use D to find the equation, and that's about what we can do. Then from simultaneous equations of BC and DC, we can actually find the coordinates of C. Or we work out the coordinates of the midpoint of BD, and we know that that midpoint will be the same as that of AC. Then we can use the midpoint expression to find those coordinates. So we've got 2 ways of actually nailing those coordinates of C to the wall. Okay, easy stuff. So please, guys, always look at the diagram and look at ways in which you can work with the diagram. Obviously, not necessarily going to answer all the questions that way, but most of the questions. In fact, you'll be comfortable even with the ones that you cannot answer because you've understood your diagram. You just know what clues to look for more than what you've already discovered and understood. Or even try some of the things you've already thought about and see where that leads you. Okay, determine the gradient. Now this is a grade 10 question. Very easy one and certainly a gift from the examiner. So we know that the gradient of AB is going to be y at B minus y at A over x at B minus x at A. So we substitute y at B, it's minus 2 minus 4 divided by minus 6 minus 0. This gives us minus 6 divided by minus 6. But I don't know why I'm prolonging this. Let's just leave it here. This is just 1. Nice and easy. Okay, so we get marks for substitution and the answer. Remember, gradient is a ratio, so there's no unit. Okay, 3.2, we are told to determine the equation of CD. Can you see? Just what we thought about. We've already found it now. So we know that MCD is going to be equal to MAB. The reason is that the opposite sides of a palm, okay, are parallel to each other and therefore equal gradients. So you don't say too much. Just say these are opposite. So we can say therefore the gradient of CD is also 1. We then proceed and say our line CD is such that y equals, now the gradient is 1, so this is just going to be x plus c. Then we take the coordinates of D and substitute them. So this is minus 1 equals 10 plus c. Therefore our c, we transpose the 10, it becomes minus 10. So that's minus 11. Therefore our equation y is going to be x minus 11. Okay, so that's okay. Should be all right, because we expect our y-intercept to be negative and fairly negative. So that's good. We cannot doubt this. So what do we do here, guys? Substitution, usually the final equation. And this statement is very important because it gives us the gradient of that line. All right. So that is key. We need to understand our work nicely and work through, carefully. Determine the coordinates of M, the midpoint of AC. Can you see exactly how we saw it? So we are told that this is point M. Okay, so we need to find those coordinates. Not a big deal. So we know that M is also the midpoint of BD. Now what is the reason here? Maybe let's take it down. So let's put it here. M is also the midpoint of BD. The reason is that the diagonals of a palm bisect each other, isn't it? But now, if you just wrote diagonals of a palm, it already transmits that information. You don't need to complete that statement and say they bisect each other. You don't want a very long, lengthy, tiring don't, but do it if you feel like you have to, because there's nothing wrong about it anyway. So now this implies that M is going to be x at D, for example, plus x at B over 2 is to y at D plus y at B over 2. This also implies that our M is x at D, it's 10 minus 6 over 2 is to y at D minus 2 minus 1 over 2. All right, therefore point M is 10 minus 6 is 4 divided by 2 is 2. This is minus 3 over 2. nice and easy. What do we see? Minus 1 comma 5 is less than minus 1 but greater than minus 2. So that position of m is exactly as we anticipated it. Okay, nice and easy. So obviously guys, this is how many marks? 3 marks. I think this statement is important, right? And then we just get these ones nicely. The substitutions really don't matter, but if one wants to do it, they can really mark it. It's not that much of a big deal. So next question says, we need to find the coordinates of C. Again, what we already anticipated. So 3.4. Can you see, guys, analysis that is on point actually makes life a lot easier, because all you do, you cruise now. You've already discovered what you need. Rather than to go back and forth thinking per question, that is really time consuming and it can be draining. All right. Either way, you choose how you want to battle this war. It's really up to you. So we know that coordinates of C are such that x at A plus, maybe let's start with C, x at C plus x at A over 2 should give us the x coordinate at M, the midpoint. Likewise, y at C plus y at A over 2 should give us the y coordinate at M, its midpoint. This implies that our C is still what we want, but x at A is 0 over 2 should be equal to 2. Now this is y at C plus 4 over 2 should be equal to minus 3 over 2. Therefore, our C is, we cross multiply the 2, there we get a 4. So this is a 4. Cross multiply the 2's cancel, we get minus 3. Minus 3 minus 4 is going to be minus 7. That's it. Again, this is a point in the fourth quadrant. X is positive, y is negative. Should make sense, you know. It should make sense. And we can see that this is the point before D. So it should be around 7. But again, it's a point ahead of M. So this 4 is valid because it's greater than the x coordinate. But now we see this point is below B, which is the lowest point we can see here on this parallelogram. It's minus 2. Minus 7 is less than minus 2. So this should be okay, isn't it? So again, interrogate the quality of the answers you get, because they give you an indication of whether you are correct or you are wrong. Remember, I said to you, maths always, okay, let me not say always, it almost always provides you a way of knowing you are correct, even if you haven't seen the memorandum. You can just see it by what you just did, and by looking at what is given, you can already ascertain that I am correct here. It could take a serious misfortune, because sometimes there's coincidences. You find that your mistake wasn't too great, so it became close to the answer needed, but the quality will assure you though that I'm not far off, even if I am not there yet. Okay, all right. Now guys, how many marks are we scoring here? 2 marks. Obviously, we're using the same formula we have already used and got marks for. So I would think the answers only give us the marks, okay? Or one could distribute them and say the substitutions there and then the final answer. Either way, you get 2 marks there. Great. Because one could say I did this by inspection. I mean, if a question says determine, remember you are free to choose a method of solving. No one forces you into one particular way, especially when it's only 1 mark or 2 marks. But anything beyond that, it already says you need to do more, you need to say more. So just one statement would not be enough. An answer only would not be enough for marks more than 2. But if it is just 2 marks or 1 mark, you can just show up with the answer only, unless directed otherwise, of course. Not a big deal. So let's do the last question, 3.5. We are told to find the size of BCD. BCD. So this is this angle right here. Okay, but what do we know? In a parallelogram, the opposite angles are equal. So what about BAD? Because we can see BCD is going to create a bit of a problem for us. Although we can still deal with it, but it could be a lot of work. It may require us to do a construction like this, draw a horizontal line, then work out the gradient of, the angle of inclination of that line, and then work out the angle of inclination of that line. Then take that whole angle and subtract this one. It gives us that. That can be done. But it's up to you really. I'm just showing you techniques and tricks now to not give up when you see a question like this. It's not really a lot of marks if you look at how easy this is. But how I like to look at things, I know that these two are equal, opposite angles of a parallelogram. But if I focus on that top part, so if we focus on that top part, can you see we've got a triangle? And in this triangle, we can actually work out this angle of inclination. This already tells us why we had J on the x-axis, because this we can say AHJ. But we can also work out the angle of inclination of that line. All right? Because we already have done the gradient of that line. Now, can you see this is an exterior angle of this yellow triangle? And we can find that angle. That means we can work out that angle. Once we get that angle, we transfer it here with a reason. Great. Now, let's have a look here. We can say in triangle, let's just call it FAH, far. What do we see there? We can work out this angle. We know that tan of angle AHJ is going to be equal to the gradient of AD, right? Because it is its angle of inclination. So we know that the tangent of AHJ, please don't forget the cap, okay, is equal to, but some people actually write angle AHJ. That angle already means the one in the middle, okay? So know the notations of how to express an angle mathematically. It's very important. So y at D minus y at A over x at D minus x at A. Remember guys, when you're comfortable with this, you don't even need to write the formula. You can just go straight to substitutions. But I'm just taking you through it step by step in case you're still shaking at this point in time, because not all of us have experienced enough training on these and we're not exactly ready for the finals even. So this is just to give one final comprehensive push. Hopefully you will recover yourself and your angels may also lift you up. If not, well, you can look at it again in May, June. It's not a big deal. Okay, y at D is minus 1. Minus y at A, which is 4, divided by x at, what is this? D, it's 10, minus 0. Okay, this implies that our tan of AHJ is equal to, this is minus 1 over 2, right? Yes, because this is going to be minus 5 divided by 10. So 5 once to 10 twice. The negative stays. So what are we going to do? We can say therefore our A, because our target is the angle AHJ, is equal to the shift tan of minus 0,5, which is a half. But to this one we add 180, because it's an obtuse angle. So what is that? Now let's find it out. Now we go back to our computing mode. Please get out of stats mode, or else you're going to have problems with certain symbols. So we say shift tan minus 0,5. So shift tan minus 0.5 plus 180. Okay, so this is going to be 153, let's say 435 degrees. Just to keep a bit of accuracy. Remember, when no instruction is given, we do it to 2 decimal places. All right, okay, all right. So that is also fine. So we can say also, we know that the tangent of, say here, HFA, HIFA, all right, what is this one? Is going to be equal to the gradient of AB. We don't mind. That is true. Now we found out that the gradient was 1. Therefore, we know that HFA is basically arctan of 1. That is a special angle. It's 45 degrees. Nice and easy. We can say then, we know that essentially angle HFA plus angle, say, FAH, we can leave it at that, must be equal to angle AHJ. This is the exterior angle of a triangle. And we have stated our triangle nicely because we're still working with it. This implies that 45 degrees plus this one, which we don't know, but we want to use it as a surrogate for our final angle. So this one is 153,435 degrees. We can say therefore our FAH is equal to, now we're not going to waste time here, 153,435 minus 45 gives us 108, 4. Now we can do to 2 decimal places because this is almost the final answer. Okay, we can say but. Now we're introducing a bit of doubt. We know that actually this angle BCD is equal to phi. Ne? Why do we know this? These are opposite angles of a parallelogram. There's only one parallelogram, so we may not need to state it, but when there's many, please be specific which one. You can say therefore our BCD is actually 108,44 degrees. That's it. Nice and easy, guys. So this is cool. But remember, this was already a determination of a gradient. So finding the gradient was key, and that angle. Here we had already been given the angle. We just find the gradient. Okay. Now that's good. And then we've got our 3 marks there. And then we have this statement. It's a powerful statement, and finding that angle thereof was good. So we have 5 marks, and this last statement is key. The final answer, remember, has been marked anyway, so it doesn't amount to any marks. But the reason for it, of course, it depends on the approach as well. So guys, we should be walking away with 16 marks here if no crimes have occurred or careless mistakes. So one can appreciate that this was easy, not a big deal. Okay, so there's many ways, honestly, guys. One could easily look at this triangle BCD. Since we know the coordinates of C, we can calculate that side, calculate that side, calculate that side, use the cosine rule. That could work, okay? Or to draw a construction here, get that obtuse angle for BC, then find the acute angle for CD, and then you take that one, you subtract the acute, it leaves us that angle. So you can look at it in many ways that you can see, as long as you solve the question. All right, so that should be easy, guys. Let's get 2 more questions as fast as we can. Question 4. Of course, guys, this is not the speed contest. Be very careful. But I just don't like to waste time saying what you already know. I've been elaborating most of the videos. Please find them if you have time. And make sure you don't just watch passively. You listen carefully. You appreciate the extent to which you need to go. Because remember, what I'm doing is actually now me showing you the ways. So I'm more relaxed. I'm not in a hurry. I'm trying to be as elaborate as possible. But when you do this in the exam, remember, if you've practiced this technique well enough, but what you guys mostly do wrong is that most of you focus on speed when you practice, because you get told by your peers, no, manage your time, this and that, which is fine, right? There's nothing wrong with learning how to manage time. But my question to you is, how can you manage time when you already don't know the work? Because someone who can manage time is someone who understands the work and knows the work at the back of their mind, or at the top of their head, or whatever, top of their lungs, whichever expression suits you for this situation right here. So how do you speed up when you don't know what you're dealing with? You already are shaky in some of your methods of dealing with issues. Your algebra is not on point, your arithmetic is poor, and I don't want to talk about Euclidean geometry. As you can see, it keeps coming to haunt you all along your examinations. Now, here's the thing, guys. When you practice, don't cheat yourself. Put time aside. Don't even think about it. There's no point. Practice. But in your practice, make sure after solving a problem and you check the memorandum that is available to you and you find out you got the answer right, start exploring other ways in which you can answer some of those questions, because some of the questions within the question you may have answered successfully will have multiple ways of looking at them. This is now to unlock your mind into possibilities, especially when there's a trick in the question. Some of these other ways become the absolution in those situations. Now, once you have explored all possibilities, or at least those that you can come to, then you know you have done due diligence in your practice. Then you can sleep. It doesn't matter if it took you 2 hours to just answer one question and explore around that question as much as you can. But believe me, when you get to the exam, guys, you're going to be like a speed cop car, isn't it? It a speed cop. Imoto ezibalekayo kodwa ezemoto zezemjaho. Uzobaleka njenge-Formula 1 moto. Because remember, guys, this is now second nature. You see, when the thought process is second nature, you no longer take as much time as you did when you were practicing. You don't even need to have practiced how to be fast. It just comes naturally. You just move because you'll see, easy lento, answer. And then you check your answer. Be careful not to just move without checking. Interrogate that answer. This answer is correct. Then you move to the next one. It's done. You check. You are convinced you're done. You move on. You will realize that within 1 hour, 50 minutes, you will have taken half of that paper. And even the remaining half, it's too easy because there's some easy questions there for you to just rush through. By the time 2 hours are over, you've finished your paper nicely. Now you have those big guns that are still staring at you and saying, boy, no ways, you ain't moving here without looking at us properly. We deserve the respect from you. And now you start go and pay your respects. And who knows, you might just be rewarded with full marks even there. So that's how you do it, guys. But again, you choose how you want to battle this war. All I can tell you that many people go to war and come back casualties of that war. But you don't want to be those statistics. You want to go to a war. Either you die in the war or you win. But you can't come back injured and severely damaged, because that impairs your future outlook, okay? Be very careful. Certain techniques look attractive, but they're actually ridiculous in that they're impractical. Look at what is practical and practice it successfully. Obviously, give yourself time when you're doing these things, because you're not going to assimilate all of these things properly if you are in a hurry. There's no way. You will manage your time well, but you're not going to win. So what's the point of managing time so well, but you actually don't get anything out of it? So that's a fail, isn't it? So please don't fail while you have used a smart technique. Use a smart technique to succeed. And the easiest is just to use the most basic of ways. Take time. Even the songs about Tatulaki Tobe, they tell you, take time to know. Because if awumazi kahle lo muntu lona, uzakwenza enye into ongazange uyilindele, and ngelo xesha sekuyi-injury time. Intanga zakho sezikushiyile zinako konke and awusenalutho. So be very careful, guys. A very quick win now may be something to regret in the future. Rather have a strong win, because even in the future it's going to be a reminder of how well you have been when you did your best, and that gives you enough motivation to go on. Anyway, let's get to question 4. In the diagram below, shows two circles touching at J. Okay, there is our point of contact of these two. Now the smaller circle has its center at the origin, so not a big deal, we can see that. Okay, and the bigger circle has the center at K. Great. All right, and then we've got an incomplete coordinate there, so this already suggests that A, we need to find it. It's a potential question. All right, the length of the radius of the bigger circle, can you see the length of the radius of the bigger circle is twice the length of the radius of the smaller circle. So if we say the smaller circle radius is R, then this means, if we say this is R, then this one is going to be 2 times R. Ne? That's just the idea, essentially. Now this means if we can find the radius R, we have found the radius or the length JK. And from that, we can actually use our distance formula to solve for A. So this is cool. So this is giving us a way of solving our problem nicely. Hey, Bo, what am I doing now? Okay, great. So I don't know what happened here. This one just went away somehow. All right, not a big deal. Now we're told SR is a tangent to both circles. So what do we know about tangents, guys? We know that a tangent meets the radius at 90 degrees. So obviously, guys, these are lines we are drawing ourselves, so we need to be very careful. Okay, so what do we know? We said this angle is 90 degrees and that angle is 90 degrees, right? Now, can you see if corresponding angles are equal, what does it make these lines parallel? So we've got parallel lines. And now this means a proportionality theorem here can be applied. Keep that in mind. Maths is so sweet, guys. Analysis of statements given almost always gives you something. Believe me, it does. All right, let's have a look here. What is this radius? Well, we don't know. Once we work it out, we'll know. But if the radius of the smaller circle is twice the radius of the bigger one, so this means that radius here, remember this is still R as well because that's the radius. So that OR is still R. And this one is going to be 2R. Can you see? This means this line is essentially 2 times that line. So what theorem comes to mind? Midpoint theorem of triangles. Why? Because when a line is drawn parallel to the other side, such that the value of that line or the length of that line is half the line of the other one, then it means this particular line connects the midpoints of these two. Okay, so it has to connect the midpoints of the two opposite sides. So already we know that, okay, all right, okay, we have a midpoint theorem of triangles in that triangle. So can you see, guys, analysis unlocks a lot of nonsense that would be hidden from you, and you would be trying to crack your head to get around the question if you started answering, because as you keep going back and forth to look for clues, you panic because you expect to get an answer. But if you look at this, while it is not knowing what the questions are, as you look through the questions, you start to realize how so easy it is to even think around the question. Even if you have to go back to the drawing board a little bit, you already have a lot up your sleeve. Anyway, KO and SR are both produced, meaning they are just straight lines. Once you hear the word produced, it just simply means straight lines. Remember, maths language or mathematical language has implications on either a value or a quality. As you can see, this being a tangent gave us these parallel lines. These parallel lines, again, we notice this is nothing but the radii. Now, if that radii is half the other one, definitely it is the case. Now, this sets up a midpoint theorem of triangles, meaning side PR is equal to RS, or side PO is equal to OK. Can you see? That is easy. Now let's start looking through the questions and see how many are we going to answer with this in mind. Now we have to calculate the length of the radius of the smaller circle. Very easy. We know that x squared plus y squared equals r squared. Remember, circle centered at the origin, we have that format. Now we can use point J because this is 2 and minus 1. So we have x as 2 squared plus minus 1 squared equals r squared. This implies we can rearrange and say r squared equals, this is 2 squared, 4 plus 1 squared is 5. So therefore we know that r is going to be the square root of 5. Remember, this is a distance, units. Obviously what we did here, we took the square root. So what we do on the one side, we do on the other. Nice and easy. Remember, this is a distance, we can't choose the negative value. We take the positive. So that's easy, 2 marks. So obviously substituting the point in the format and the answer together with the unit, folks. If you don't write this, don't be surprised when you are marked down. Don't complain, because it means you're not paying attention. So please do not cheat yourself by being careless or complacent. Okay, now that's great. So let's have a look. We need to show that A is 6. Can you see? Giving us a direction on how to deal with this. So now let me just show you what I am thinking about this question. We said we could use the distance formula there. So all we know is that, well, OJ, or let's just say JK, is equal to 2 times the square root of 5, right? Because we were told that this is 2 times that radius. That was given. Already we are making a substitution, so if you need convincing, you know that that was given. Now this implies that JK squared is going to be 2 square root 5 all squared. Why are we squaring? Because we don't want the square root sign interfering with our work. So now we can start writing x at k is a minus x at j, which is 2 squared, plus y at k, it's minus 3, minus is going to be plus 1 at j, all squared. This is going to be equal to, when we square this, it's going to be 4 times 5, that's 20. All right, so we move on. We want to keep this a minus 2 as it is, all squared, plus this is now 2 squared, which is 4, equals 20. So this implies that we have a minus 2 all squared is equal to 16. When we transpose the 4, again we do the gymnastic that we want, rather than to end up with a parabola, which sometimes you guys, your mathematical gymnastics are not so strong, so avoid things that give you problems. Plus or minus 4. Now, this implies that A is equal to, when this is minus 4 plus 2 is essentially 2, minus 2. Or A is equal to, now this is positive 4 plus 2, that is 6. Right, so that one cannot be A. Why? Because A is in the 4th quadrant. Now the x-coordinate in the 4th quadrant is positive, so must conclude here that therefore A, I don't know why I wrote x here, A is equal to 6. Because when you gave 2 answers, but of course striking that one like that already says this is the final answer, but I mean, try to be as complete as possible. Now, what do we do here? We are given 3 marks, folks. So where do these 3 marks come from? Obviously, folks, for me, it's all about this step. I mean, this thing must stop doing what it's doing. It's irritating me now. That is a mark because we had to square this left-hand side, the right-hand side. Right. And also, we've had to do what? To substitute on the left-hand side. So that is 2 marks already. Now, where does the 3rd mark come from? Well, maybe this gymnastic, because that explains everything. The answer was already volunteered. So, again, guys, it will depend on the actual marking guidelines. And luckily, this one is on STEM Physics. So, it has a memorandum attached to it. So, you can have a look at it to know where these marks are. Either way, where the marks are, it's immaterial if your answer is correct and your method is legal. But if everything is a mess, then it becomes important because you need to look where do you score the marks and where do you lose them. Right. So this is 4.1.3. We need to determine the equation of the bigger circle. Easy stuff. So we know that circle K, we always define the circle by its center. This is going to be x minus x there. This is minus 6 all squared plus. Now this is y plus 1. No, plus 3, sorry. All squared equals, and then we know the radius now. What's the radius there? It's 2 root 5. So we're going to write 2 root 5 all squared. So therefore, our circle K is given by this equation, x minus 6 all squared plus y plus 3 all squared equals 20. Remember, our r squared must be simplified. But some people say you can leave it there. It's okay. I don't really mind. So, for me, guys, this means the right-hand side and the left-hand side substitutions are the mark. This simply says the answer only is also effective. And for me, a 2-mark question, always try to gravitate towards the answer only, rather than write a wrong statement above and then come up with the right one. Then you lose those marks completely. So try to use rough work for a question as short as this. For other things, then write the final product. And when you get overwhelmed somehow, things don't make sense, you can write the C rough work. Then the rough work must be marked if you see that what's in the rough work is correct and you don't have time to go back and transcribe onto the main script. As long as you numbered what is on the rough work correctly to correlate with the number of the question, that also is good. Now we're told to determine the point 10, whether it falls outside or inside the bigger circle. Okay, how do we know? Look at this. Remember the radius. Remember here we've got 6. K is 6. Sorry, A is 6. But now if we say 2 root 5 to the circumference, so we want to know what is the distance to there. So what is that coordinate there? Let's see, 6 plus, oh, my calculator is off. 6 plus 2 root 5 is what? This is 10,47 or 10,5 roughly. So you can see this is essentially approximately 10,5. So this means 10 is somewhere there before that line, and that means 10 can either be outside here, it can be on the circumference, it can be on the inside, it can be on the circumference, it can be outside. So we have to explore whether that line makes sense for this to be the case. But now, how will we know? We can just say, look, we are mathematicians now, okay? We can safely call ourselves that. If we draw a line to a point outside, that line is going to be greater than the radius if this falls on the circle. Okay, so we can just use those two lines as our model to look at this. So if we find that line, remember that we said it fell outside. Maybe let's choose a different angle so that we don't run into problems. Let's say if this falls onto the circumference of our circle. So if you see this line falls onto the circumference, right? And then let's say this one falls outside the circumference. Either way, whether it was there or there, whatever, we will notice that these two lines must not be equal. But now we will see the quality of the answer. Because if this line here, from K to this point, is greater than the radius, then it means this line is outside. But if this is the case, now here's the other one. If it fits that description, where we see that this line is literally less than the radius, then it means that falls within the circle, okay? So we've got a few ways of looking at questions constructively so that when we answer, we know we are on point. So we can just easily ask ourselves, what is K to that point? We can just say let point K, not K, but now we have no Q, so we can say let point Q be equal to 10 is to minus 4. Okay, obviously we can see if 3 is over there, so minus 4 should be down there. Ne? Minus 4 should be down there, it can't be up there. So already my sketch is defeated. So it can't be there. So we look at the quality of the answer. So we can say, we can choose whether it is here or it is outside. It's either on the circumference or outside or within. Even within, we need to adjust this because it can't be at the level of 3. This is already minus 4. So minus 4 is lower than minus 3. Maybe we can choose this one here. Say that point could be there. So be very careful, guys, on how you draw the sketches. They need to make sense. Otherwise, you'll run into problems. Now, we can say, let's find out what is KQ. KQ is equal to x at Q, which is 10, minus x at K, which is 6 all squared, plus y at Q, which is minus 4, minus 3 is going to be plus 3 all squared. Let's see what is that. We can say, therefore, KQ, actually this is supposed to be under the square root. Be careful of messing up when you already are on point. So this is 10 minus 6 all squared plus minus 4 plus 3 all squared. So this is square root 17. So sometimes you may want to reveal what is that, because root 17 is not good. So this is 4,12 units. Okay. Now we need to look at essentially what is the radius. Now we know that if this point is on the circumference, then we know that the radius of the circle is 2 root 5. Right, because we're already given that. So we can see that this, remember 2 root 5 is square root 20. Maybe we could have left it here and say 2 root 5 sorry, is square root 20. Obviously, square root 17 is less than square root 20. But I'm trying to think, maybe let's not do this. So this is units. So we can say since KQ is less than the radius, is less than the radius of circle K, because the radius of circle K is square root 20. I mean, root 17 is less. We can say now, maybe we can even try to be as elaborate. We know that square root 17 is less than square root 20. Just in case you're not convinced, we can say therefore point Q, remember we chose Q, lies within the circle. Okay, nice. So very easy exploration there. Obviously, one could easily have decided to just substitute that point into the equation, and you will see that the left-hand side would not be equal to the right-hand side. And if it is smaller than the right-hand side, it's already suggesting that that is a point within that circle, not outside and not at the circumference. So again, guys, a lot of looking and making sure things make sense is important. So we can already take down these other possibilities because they were not really of any importance to us. Okay, so we just had to dance with those three lines, but it just simply answered our question. So if that came out to be longer than the radius, we would know it's outside. But it came out shorter, that means it's on the inside. If it was equal, then we would say it's on the circumference. Can you see? Very interesting question there. It looks very simple, but it's quite educated, isn't it? Yes, it's quite educated. So of course, guys, this is important and that is important. And the conclusion, okay, providing that reason that this is less than. So therefore, that is the answer. In fact, even the substitution is not that important, but I think the comparison is more stronger. So we get our 3 marks. Now we need to find the length of PS. Now this is a big boy or a big girl, right? But you see, we've turned this big boy or big girl into a small girl and boy because now we already understand here that, okay, guys, look, we know the distance OK because this is 2 root 5 plus root 5, which is 3 root 5. So this distance right here. Okay, let me use another color so that it's not too bad. So we know that this is 3 root 5, isn't it? But now we discovered that from our midpoint theorem, this is also going to be 3 root 5 over there. Right. But now this is a right-angled triangle. We know that the radius is nothing but 2 root 5 over there. So if we look at this triangle, if we look at that triangle, you will notice that, well, this is a right-angled triangle. We know this side, we now know that side, then we can calculate PR. But from our midpoint theorem, PS is 2 times our R. So this distance can be calculated using that. But now we need to set up the reasons why we have those sides looking the way they look. So we need to be very, very, very smart about it because then it can save us a lot of pain. So we reduced a big boy or a beast into a lamb. Okay. So 4.1.5. See, analysis sometimes helps, but it doesn't help always. Remember, you may have to look at it again differently, but either way, when it works, it's good. When it doesn't, you look again. The good thing is you'll be comfortable. You won't be panicking. All right, so what is the length of this PS? So now we're going to start saying statements that say essentially S, we can just say K SR equals 90 degrees. Why? The tangent is perpendicular to radius. Isn't it? Yes, and then we can say likewise. We know that angle ORP is also 90 degrees. Again, tangent perpendicular to radius. So what does that mean? It therefore means KSR is equal to ORP. Right, each equal to 90. Therefore, that means OR is parallel to KS or SK, whatever. Now we need to provide a reason here. We can say corresponding angles are equal. Great. That is our first part of our argument. Now we've set up the parallelity because we needed, as much as we discovered it, we now need to show that we have discovered it and how did we do it. But now we'll notice something. We will say here clearly, we will say but what? We know that OR is equal to half of KS. Right. That was given. Or we can say KS is 2 times OR. Maybe let's put it that way. The way it was given, we can say KS is equal to 2 times OR. That was given, guys. That statement there is what was given. Now what can we say from here? We will then say therefore. Remember that statement, we used it as a surrogate to get to something. Then we can say safely. We know that PO, or let's just say OP must be equal to OK. As well as PR must be equal to RS. What is the reason here? This is the midpoint theorem of triangles. Obviously, whenever we mention such a thing, it's a special case of proportionality, right? We need to prove that since OR is parallel to KS. Now, guys, we are ready to move. Because once we say those equalities and we have provided some full reasons for that, now we can move on. We can say here, then let's just say in triangle, now we can say ORP. Okay, what can we say here? We can clearly see that essentially PR squared plus OR squared should be equal to OP squared. This is Pythagoras, because we have discovered and explained that those angles were 90 degrees. So we solve and say PR is what we want, right? Plus OR is the radius, so that was square root 5 squared equals OP. Now we know that OP is equal to OK. And what is OK? We can just show this one is square root 5 plus 2 root 5 all squared. We just show how we calculated that distance nicely. So we move on. So this implies that PR squared plus 5 is equal to, this is 7 root 5. Now 7 by 5 is 40, is it 35? Now remember, this is going to be No, this is 3 root 5, so this is going to be 9 times 5. 9 by 5 is 45. Sometimes the maths disappears, guys. Uzabona izibhorho apha. Alright, okay, alright. So what do we say now, guys? We can say therefore, or let's just continue without being silly. Now 45 minus 5, what is that? It's 40. We can say therefore PR is going to be equal to the square root of 40 units, right? Of course, the gymnastics here, we took the square root, and what we do on the one hand side, we must do it on the other hand side. But why did we have to look for PR? Because we know PR is half of PS. We can say then, therefore, PS is going to be 2 times PR. Right. We've already stated this one, isn't it? I think we did. We said OP was equal to OK as well as PR was equal to RS midpoint theorem of triangles. So that statement already captures it, but if you like, you can repeat it and say this is because of the midpoint theorem of triangles with what can I say, guys? But I mean, it's already obvious. I mean, we stated it. PR equals RS, so maybe we may stay away from this and just simply say PR equals RS. And we proved, maybe let's just say proved that PR equals RS. Maybe that's better to avoid unnecessary problems. This is 2 into root 40. So this is going to be 2 square root of 40. But now 2 square root of 40, remember 40 is 4 times 10. So this is going to be 2 into 2 root 10. If you just want to simplify, 4 root 10 units. I mean, you can leave it at 2 root 40. You can round off to 2 decimal places if you will. It's not a big deal. So you can see, guys, this is an essay type question. It's not one that you can just walk around carelessly. Of course, there's many ways of looking at it. One can use proportionality, to prove that PR is equal to this one. And how do you do that? Remember, if this line is parallel to that, we can just simply say PR over OR. We can look at it that way and say this is going to be equal to PS, for example, over what can I say, over SK. Again, we can just say prop theorem, and then we work it out. PR over OR is root 5 equals PS, we don't know, over now this one is 2 root 5, right? We discovered that. So what does that mean? If we cross multiply here, we'll get essentially PS. I'm trying to think now. Okay, let's just say 2 root 5 PR is equal to root 5 PS, right? And then we can divide by 2 root 5. And what happens? That goes, and then we find that PR is going to be root 5 takes each other out. So can you see it's half of PS? So we can see that if this is half of PS and that line is parallel to that, it means also that side is divided into 2 equal parts. So there's many ways of actually showing this. If you trust your mathematical gymnastics and your theorems are on point, I don't even know why I'm removing this, and your theorems are on point, guys, you are limitless, believe me. So It really depends on how you want to do this. And from there, you transfer those values to the other side, and then you use your proportionality theorem now using the other sides. Then your work becomes easy. Okay, not a problem. So let's move on to 4.2. Now 4.2 says the length of the diameter of a circle with this equation is 24. Okay. Now we need to determine the coordinates of the center, so we need to complete the square there. So 4.2.1. We know x squared minus 4x plus y squared plus 5y equals minus d implies that we've got x minus, we halve that, and then we square, plus y plus, we halve that, and then we square. Then it's going to be minus d plus, now this one squared is going to be 4 plus, that one squared is going to be 25 over 4. And that's what we have. We can therefore say the center is going to be the opposite signs of what we have in there. So that's it. Nice and easy. So that's done. So how many marks there? 4. Obviously, we get a mark for this dude, we get a mark for that dude, and we get a mark for this side. Right. No, you're lying. Maybe let's say a mark for the left hand side, mark for the right hand side, and then a mark for those two coordinates. Maybe 4 marks, perhaps. That's the best way. So let's look at 4.2.2. We now need to find the value of d. Okay, that's easy. We know that r squared is essentially equal to this one minus d plus 4 plus 25 over 4. That's what it is. Remember, that is the r squared. Now this implies, what is r squared? R squared is half of the diameter. So this is 24 over 2 all squared equals minus d. Plus we multiply the 4 there, it's going to be 16. 16 plus 25. 41. So this is 41 over 4. Okay, great. We'll just simplify that, because those are like terms. So this implies that this is 12. 12 squared is 144 equals minus d plus 41 over 4. Now we want d, right? So we transpose d to the other side. This implies that d is going to be 41 over 4 minus 144. Therefore d is going to be, now we multiply the 4 there. So 4 times 144, that's 576 minus 41. That's minus 535 over 4. Right. Let me just double check. 41 over 4 minus 144. Yes, it's minus 535 over 4. So that's good. So this one was another algebraic walk, so to speak. Obviously, guys, for this determination of the radius, we get a mark, ne? Essentially, and for the entire substitutions, we get a mark, and for the final answer. The gymnastics are your own indaba. So if we didn't commit any crimes, those 22 marks could have been scored nicely. And as you can appreciate, guys, the question 4 is always interesting, isn't it? Because it's a true grade 12 question, unlike these other ones, which is purely grade 11 and then a bit of grade 12. Now let's quickly go to question 5 and see how far we can go. Now question 5, it's what you know, guys, the pap and place of trigonometry. So we are told tan of 58 degrees equals n. So we always show this as a ratio. So when the variable is standalone, it is divided by 1. And this takes us to our terminal arm diagram. So always know. So where's the terminal arm? It's in the first quadrant because 58, it's an acute angle. Okay, so we then draw that down to the x-axis, and then we show that that is 90 degrees. So this is 58 degrees. Now, if this is 58, what should this one be? Remember, to go to 90, this should be 32 degrees. Okay, please calculate all angles. Now, this is tan is defined as opposite over adjacent. So we can solve for the terminal arm here. We know that r squared is equal to x squared plus y squared. And we know this from Pythagoras. Please don't need a second invitation to do this calculation. Just get on it. X is 1 squared plus y is n squared. So therefore our r, when we take the square root, remember r is that radius or the terminal arm. Now this is going to be 1 plus n squared. So once this is sorted, guys, please sort this out first. Do not wait for any mishaps to start occurring. You don't want to start looking to calculate this when the questions are already hotting up. You want to start sorting them out nicely. So 5.1.1, we need to find sine of 58 degrees. Now this is easy. Sine is opposite. Okay, sorry, we didn't write this one there. We need to write it. So this one is 1 plus n squared. So sine is opposite over hypotenuse. So this is n over the square root of 1 plus n squared. And that's it. We cannot simplify this one further. You can rationalize if you want, but you will simply be wasting your time. Now, this is just 3 marks. So where is this? So this is a mark on its own, right? And the other mark comes from there, right? Right. So usually here 2 marks for the answer, and then the extra mark is from that determination on the terminal arm, and that totals the 3 marks there. 5.1.2, we need to find sine of 296. Now, where is this angle? 296 is in the 4th quadrant. So in the 4th quadrant, we know that this could be easily expressed as sine of 360 degrees minus something. Let's see. 296 minus 360. What is the difference? It's 64. So this is minus 64 degrees, okay? Don't worry about what that 64 is. It's not one of these angles, but we'll explore. Our focus is to reduce first. Now this is in the 4th quadrant. Sine is negative, so this is minus sine of 64 degrees. Now what is this? This is minus sine. 64 is actually double 32, so this is sine of 2 times 32 degrees. Can you see calculating that angle was key? If you didn't do it, you would then have to think about what is this and not know where it's coming from. So please, guys, standard work must be done standard way. Now this is minus into sine of 2 times the angle is going to be 2 times the sine of the angle times the cos of the angle. Okay, so this is minus into 2 times sine of 32. Now it's the opposite of hypotenuse, so this is going to be 1 over that 1 plus n squared multiplied by cos of 32 is the adjacent, which is n, over the hypotenuse, which is 1 plus n squared, and then we close the bracket. And then we do the final answer. Now this is 2 over 1. So numerators multiply, denominators multiply. So this is going to be minus 2n over. Now this one times that times 1 is just basically 1 plus n squared. Now this is a rational denominator. You don't even need to worry about rationalizing. This one was a bit challenging, but not too challenging, because this included double angle identities. Remember, you will always get these, but this one was a smart question because it first used reduction formulae, which is key, and then doing this expansion using identities is also key. Then the substitutions that are correct, that's key, and the final answer. So this is how we get these marks, but we need to show that this 64 came from 360 minus 64. If this is not there, you will not get this mark, because remember, we were told not to use a calculator, so you must not show up with this thing and we don't know where it's coming from. Don't cheat yourself of easy marks. This is a gift from the examiners because it's predictable. This one is highly predictable. You know that you're going to use a direct angle using the diagram. You're going to end up using reduction formulae, maybe only, and then the answer, or some double angles or compound angle identities or square identities or tan identity. But identities are going to be used somewhere. Okay? And the last question might be a smarter one, because usually you always get these special questions. They are there to just harass you a little bit. You can't have, inestam umdala. Funeka mazamba nachisayo. Now, what is cos of 2 degrees? Obviously, guys, we know that we need to create either a special angle or any one of these angles. But we know that these two cannot give us a 2. What can give us a 2? Okay, masiqale siyibhale. Cos 2 degrees is essentially equal to the cos of a special angle 60 degrees minus 58 degrees. Can you see? Here, the examiner is making you create your own compound angle identity, essentially. Then we just expand. It's going to be cos of the first angle times cos of the second angle. The sign changes. Sine of the first angle times the sine of the second angle. Now what do we do? Cos of 60 is a half from special angles into cos of 58 is 1 over that. So this is 1 over the square root of 1 plus n squared. Okay, so that's it. Plus sine of 60 from special angles is root 3 over 2 times sine of 58, it's n over, that's twari there. Okay, now our job is just to simplify. So numerators multiply, denominators multiply. So this is 1 over 2 root 1 plus n squared. Plus again we get root 3n over 2 root 1 plus n squared. Now we've got a common denominator here, which is 2 square root of 1 plus n squared. Now this is just going to be 1 plus root 3 times n. Okay, and that's it. We cannot further work this out, so we are done. We leave it here. Don't attempt any manga business. This is already too complicated. All right, guys, so this is good. So this was also a smart question. This is a typical higher grade question, because here the examiners push you to create your own scenario and you work that scenario the standard way. And of course, you follow the correct procedure to the answer. All right, easy. So this is very good. It's a mark on its own, but maybe not necessarily there, but here the expansion is the mark, the substitutions, and the final answer. But the substitutions are pretty easy now because we already have a diagram. For me, I don't think the substitutions technically warrant the marks, but because we had to use special angles which were not here initially, so perhaps that's fine. In fact, this one should have been 4 marks because this step right here is key. But let's leave it at what is given. All right, guys, so we move on. 5.2. Now we are to prove this identity. So you know the three-step approach. So now I'm just gonna go about it. But if you want to know what this is, please look at the other videos where I elaborated what this is. So there's a nice comprehensive paper too of 2005. Check that video out, guys. Don't ignore it because it's an old question paper. That question paper has gold in it. But of course, it's up to you. But don't cry later if you ignore that video. Anyway, let's move and do what we do best. So what can we do to prove? Obviously, we choose the complicated side. So we will write the left-hand side is equal to 1 minus cos 2x all divided by sine 2x. Okay, this is equal to, now we see that there's sine here, so we can actually attempt to use that as sine as well. So we can say this is 1 minus, when it comes here we can say 1 minus 2 sine squared x, because we want a 10, so a 10 must have a sign in the numerator, so that's why we want to do that. So a proper inspection will have revealed what to do. This one is a double angle, so this is 2 sine x cos x. Okay, we deal with the bracket, so it's going to be 1 minus 1 plus 2 sine squared x over 2 sine x cos x. So the ones cancel out, so we end up with 2 sine squared x over 2 sine x cos x. And now the 2's divide out. That one takes the square. So be systematic using your three-step approach, guys. But I cannot explain it all the time unless I really am a time waster myself. So sine over cos, it's an identity of 10x. And this is equal to what was on the right hand side. And our identity has been proven. So 3 marks. Obviously, guys, whenever you use identities, you get 2 marks straight up. Now, obviously, guys, the rest is history, isn't it? And then simplifying to that, which then simplifies to what was given and the final answer. So easy 3 marks. So now we have 5.2.2. This says to us, use the identity to determine the value of 10, 15 degrees in its simplest form. No calculator may be used. So any evidence of using a calculator, you are dead. So let's look at it. 10, 15 degrees is going to be, according to the identity, this is 1 minus cos 2 times that angle all over sine of 2 times that same angle, 15 degrees. So this is 1 minus cos of 30 degrees divided by sine of 30 degrees. Now these are special angles, so this is 1 minus cos 30 is root 3 over 2. Okay, now we can combine this and say all of that is divided by sine 30 is a half. All right, let's sort it out. Now 2 there, it's going to be 2 minus 3, so this is going to be 2 minus root 3 over 2. Now we flip this, it's going to be 2 over 1. So this and that do the honors, and all we have is 2 minus root 3 as our answer. Nice and easy. Again, a very smart question. Typical of higher grade stuff, because standard graders would panic here. Anyway, what do we do here? The most important is to do those substitutions. Nice. And then how many marks were we scoring? 3 marks. And obviously using special angles here, right, and then the final answer. So easy, 3 marks. Nothing out of the ordinary. So let's move on to 5.3. Now this says simplify to a single trigonometric ratio. So, okay, sine of 360 degrees plus x times cos 90 degrees plus x minus this big boy right here, sine of x divided by cos of minus x multiplied by the tangent of 360 minus x. Okay, nice. This is easy. So we know that reduction formulae here, sine of 360 plus, in principle, that's the first quadrant, so sine is positive, so it's sine x times, now cos of 90, that means we need a co-ratio, but cos of 90 plus is the second quadrant. This is negative, so the co-ratio, which is sine, will be negative. Minus, this one is sine x, over cos of a negative angle is just cos x, okay, multiplied by 10 of 360. This is going to be minus 10 of x, right? Right, be systematic, don't be in a hurry. So this is minus sine squared x minus sine x over cos x into 10 here is basically sine x over cos x using the 10 identity. And we'll see that these ones do the honors, and what remains is minus sine, and then those two eventually do the honors. Nice and easy. So this is equal to minus sine squared x. Now negative divided by negative is a plus, so it's a plus 1. This is as good as 1 minus sine squared x, which spells out cos squared x in terms of the square identity. Nice and easy. Okay, so 6 marks. Usually all reductions get a mark, guys. So easy 4 marks there, and using the 10 identity, the 5th mark, and essentially the 6th mark is the final answer. All right, great, nice and easy. Nice and easy. So 5.4, why am I jumping too much? I'll run out of space. 5.4, we now need to find the general solution of that situation right there. So we've got cos 2x, minus a third is equal to a third of sine x. Okay, now we can multiply by the common denominator, which is 3. So this is 3 cos 2x minus 1 equals sine x. Okay, great. So now we've got sine, we've got cos, so we can change this to sine squared x to create a quadratic, because we want to solve. This is 3 into 1 minus 2 sine squared x minus 1 equals sine x. This implies we distribute, we have 3 minus 6 sine squared x minus 1 equals sine x. Now 3 minus 1 is 2, so we have minus 6 sine squared x plus 2. Okay, maybe let's just transpose this one. We transpose this, it becomes minus sine x. Then 3 minus 1, it's a plus 2 equal to 0. So we have a quadratic here. Nicely, we can attempt to factorize. Sometimes I don't try to modify things, just deal with them as they are. Factors here, that can give me a 5. When I've got a 2, I need to break this up. So I can say this is minus 3 sine x, and then this is going to be 2 sine x, right? Because that gives me minus 6 sine squared x. Then I need to play a very clever game here. This could be negative as well. But now let's have a look. If I make this one negative, it's going to be positive. So I can make this one plus 2. Wait a minute. What must I do there? What must I do? Let me see. Is it factorizable? So I'm just trying to see now. If I get a 6, the other one must be positive. So looks like I'm in trouble now. Let me see, guys. My factorization is kicking me in the face, because now I'm trying to see. This is going to be times that is going to be 6. 6 minus 2. That gives me 4, not 5. Oh my goodness, I did not have a 5 here. This is just sine x. Oh my lord. Now I'm losing my mind. Okay, so that's fine. Then it means what we need to do, we need to do it like this. 3 times 1. Ne? So this must be plus 1. So this is minus 3. Plus 2. Yeah, minus 3 plus 2 is going to give me 1. So this is not 5. I got myself confused. This is S. So this is well factorized. Okay. This is well factorized. So again, guys, you do it however you see it, as long as you get the answers. So if we solve for sine x here, we're going to see that sine x is going to be minus 1 divided by minus 3. It's just 1/3. Or sine x is going to be minus 1/2. Okay, great. Now that's sorted. So what do we see? We know that the angle x is going to be arc sine of 1/3 plus k times 360 degrees, or x is going to be 180 degrees minus that business plus k 360 degrees, or we come to this one, x is going to be arc sine of minus 1/2 plus k times 360 degrees, or x is going to be 180 degrees minus arc sine of minus 1/2 plus k 360 degrees, where k is an element of integers. That needs to be mentioned somewhere. This implies, now let's do it with the calculator, shift sine of 1/3 is 19, comma, no, what are you doing? This is x equals 19, comma, to 2 decimal places 47 degrees, plus k times 360 degrees, or x is, we do that. So here we just subtract that from 180. Nice and easy. So it gives us 160. So this is, oops, 160, comma, 3 degrees plus k times 360 degrees, or x, we come to this one. So shift sine of minus 0,5 is basically minus 30 degrees. So this is going to be x equals minus 30 degrees plus k times 360 degrees, or x will be, now, now what do we know? This is going to be 180 minus 30 degrees, isn't it here? It's 180 minus 30, so that's going to be plus 30. So we just add 180, which gives us 210 degrees plus k times 360 degrees. And then we can write where k is an element of integers, and that's our solutions. Okay, so that's easy, guys. Nothing really out of the ordinary. We just work it out, and we know sine is negative in the third quadrant. That's the third quadrant. Minus 30 is the fourth quadrant. This is equivalent of 330 degrees. Okay, so that's fine. Sorry. So I think we've done our job nicely. So every time we use identities, guys, it's a mark. So this one is a mark nicely. That's a mark right there. And then we distribute and get our quadratic in standard format, and we factorize. That's it. That's it. And then obviously we are scoring 5 marks here. So that looks a bit rough. Okay, maybe we can hold off with that. I don't know, guys. I really don't know. Sometimes these marks can be a horrible situation, but I think getting here and there is important. Now, we've got 4 solutions, so we can say 1 mark for the first line, 1 mark for the second line, provided they are all correct. And then we can score our 5 marks. Some questions are a bit technical in how the marking goes, so you will have to refer to the formal marking guidelines to get the right picture. But either way, if your solutions are correct, the marking guidelines are immaterial. If everything is working out, it wouldn't be wrong. It wouldn't be correct. So you just get full marks there. They will find a way of giving you your marks. But if you don't get the final answer, it's wrong, then unfortunately the steps become important. So this is why you need to show every single step so that you can get your marks where you probably did something wrong. All right, now what do? We do the last one. It says, for which values of k will this situation have no solution? Okay, that's easy. This basically says it's undefined. Okay, so this is sine of 2x plus 30 degrees, minus k or plus k is equal to 3. Remember, when we want to solve for the angle, what do? We isolate the trig ratio. So this is sine of 2x plus 30 degrees equals 3 minus k. Now remember, sine of any angle must be within 1. That means 3 minus k must be between 1 and minus 1. This is for it to be valid. Now, for this one not to be valid, it will be outside this domain, isn't it? So now we need to create that situation, because this is for validity. Now that means you need to understand your trigonometry, guys, properly. This is the algebra. So it is valid when this value is less than 1. In fact, less than or equal to 1. So this will be valid when it's less than or equal to 1, greater than or equal to minus 1. Outside these values, then we don't win. So we can say now, essentially this implies that this situation, it is undefined, or it has no solution. We can say for no solution. All right, it is such that what must happen? We know that 3 minus k must be less than minus 1, or 3 minus k must be greater than 1, because sine is undefined. Sine of any angle cannot be more than 1, cannot be less than minus 1. All right, we then solve the inequalities. Again, this is a clever question, a typical higher grade question. It picks your brain. If you know things, if you don't, then you are dead. So here we can solve for k. We transpose 1 to this side. Okay, let's transpose 3. Let's just work it out nicely. K must be less than, we transpose here, it's going to be minus 4, right? Or we can have here minus k must be greater than, transpose that, it becomes negative minus 2, right? Therefore, we multiply by negative, k must be greater than 4, or we multiply by negative, k must be less than 2. That's it. Okay, so you can attempt this. Remember these questions, I said questions usually allow you to check if your answers are correct. You can actually take this and plug it there. Plug a value greater than 4 here. For k, sorry. Say a 5. Then transpose that 5 and say shift sign of whatever you get there. It will be undefined. You do the same. Then you know these values are correct. There's no way you are wrong. But to just double check, you can put a 4 there and see. If it is a 4, it's not going to work. If it is a 2, it's not going to work. Okay. But you choose values otherwise here. Then you will see that actually it will be valid because you'll find solutions. Then you will walk away from this question knowing that this is good. So this is 5 marks, guys. I mean, it's quick, it's easy. But the time is going to be spent double checking if this is indeed true. Because you don't want to lose those marks. They are important. Okay. So what is important, guys, here is these expressions. This is very important. And those solutions, very important. And writing in standard form. That's most important. So easy 5 marks, guys. Nothing out of the ordinary. So an easy 33 marks if no crime or mistakes have been committed. I'm sure you guys can see how easy maths is, okay? But you need to be awake. So let's rush through question 6. I think we can squeeze it here. It's usually not too complicated. Now this is again a gift from the examiners. You always get your marks easily here. In the diagram below, the graphs of f equals 10bx, so that means we need to look for b. So if you look at this 10 graph, this is sloped the way we know. This is the standard 10 graph. Right. But now, on this 10 graph, something is strange. We normally get this one at 45 degrees, but now we're getting it at 90. So this means this shifted to the right by how much? By 45 degrees. Okay, all right, okay, so that's good. So that means we got this at twice the usual angle. So what does that mean? It means we have a 2 there, isn't it? That's what this means, because the period of this 10 graph are supposed to be 180. But we can see now this period is 360, isn't it? Because from 180 to 180, what is that? We'll just say 180 minus 180. It gives us 180 plus 180. That's 360. So you can see the period is 360. So it's doubled. So if it doubles, it means the coefficient of our angle is that 2. Is it? Is it 2? I'm trying to think now. I think I'm lying. It means that we halved it, isn't it? We must have halved it. Yeah. We must have halved it. Not doubled it, because we know that the period is going to be 180 degrees divided by the coefficient. So this has to be a half for this to take us to 360. Okay, that's good. So that means it's a half. Okay, easy mistakes to make, but you can correct yourself by confirming. So this means this one is a half. Nice. Right. Now let's see. We slowed it down, so it means this has to be smaller than 1, definitely. Okay, cos of x minus 30. Minus 30 is shift to the right. Normally we know that we get 1 at 0 for a cosine function, but now this is going to sit at 1 at exactly 30 degrees because it shifts to the right 30 degrees. So that what we would have there has shifted. So this must be 30 degrees over there. So we can already see that the coordinates of A should be 30 degrees and 1. That's what we need to get. So again, we have to look and inspect. I mean, you can see here the coefficient of the angle, of the trig ratio is 1. So it means maximum is 1, minimum is -1. So that's it. It's nice and easy. So we don't need to say a lot, do we? Now we know that, of course, the x-intercepts of a cosine function, normally this should be at -90 degrees and +90. But now we're going to shift that 30 degrees. So 90 plus 30 degrees is 120. So this should be at 120 degrees. But now -90 shifted 30 degrees to the right is going to be at -60 degrees. So guys, these things you need to know. There's no excuses. Analyze the diagrams well enough to know what's cooking so that the sailing is as smooth as ever as we answer questions. So now we're given the domain -180 to 180 and that point P, that's it. Now we're told to answer the following questions. Determine the value of B. Remember, by any means necessary. 6.1, we know that B is a half, okay? 1 mark. Or a student who trusts their algebra, you'll just write f of x is equal to 10 of b x, right? Then you take point P because it lies on the graph. So this is 90 degrees is to 1. So this means 1 is 2. I don't know why I have a -1 now. 1 is equal to 10 of B into 90 degrees. Okay, great. So we know that shift 10 of 90 is what? So this means this is 1. Okay, maybe let's write it better and say this implies that 10 of B into 90 degrees is equal to 1. This means B into 90 degrees is equal to arc 10 of 1. This implies that B into 90 degrees is equal to arc 10 of 1 is 45 degrees. Right? Then we divide by 90 because we don't want. Now these ones will do us the honors. 45 once, twice. So our answer is 1/2. So if you trust your algebraic manipulation, that's okay. That's another way of checking that you're not making a mistake, because by inspection you could easily have made my mistake that I did and said 2. 10 works differently, so you need to be very careful of what you do. Alright guys, so either way you get 1 mark for the answer. So the best thing is let this be RW, because what's the point of showing the steps when it's only 1 mark? It's a waste of time. And what if whatever you did here is illegal? Then you will be marked down even for the correct answer, because whatever you wrote does not correlate. So be very careful of writing extra when it's not needed. It can compromise your mark and you wonder why. Now 6.2 says we need to write down the period of G. Period of G, the coefficient of the angle is 1. So that's a cos function. So the period is going to be 360 degrees. Nice and easy. Again, if you want to find out, you trust your algebra, it's just going to say period is going to be equal to 360 normally over the coefficient of the angle, which is 1. Okay, so I don't know why my 6 is doing what it's doing. Sunphela wena. Skantlwaela wena. Otla kopana le dintho mona. So again, the question said, write down. So when the question says write down, avoid showing things like this. This must be in your rough work. Just write the answer only, because if what you wrote is rubbish and you end up with the right answer, you lose that right answer because it does not correlate with what you are doing. So be very careful, guys. Some examiners or some markers understand the subject and they love the subject, so they will not allow a student to piss on maths. And if I was one of those people, a lot of you guys would cry because I would come heavy on you. There's one thing I don't want and don't like is to have half-cooked people going through to university to high degrees and go there and become a heavyweight for the lecturers there and the university, creating a bad name for the university because they go there and fail multiple times and then they drop out. Now that's not a very good reflection on the ratings for the university. 2, it also affects the quality because now if you're going to have people who are not ready for university at university, that means a lot of time is going to be wasted doing immaterial work, because what's the point of marking scripts of people who are just going to simply fail? It's a waste of time. And yet we could have spent that time maybe creating some revision classes for the guys who are already on point, and maybe those are slightly falling behind, but they were ready anyway, and to make sure that the university does not have a failure rate. Secondly, it's not about just passing at university. It's actually learning. See, excellence at university is not really material in my opinion. I know some people attach a lot of importance. Graduating cum laude, it's okay. Maybe I'm jealous because I didn't graduate cum laude. so maybe it's jealousy, but for me, I don't see the difference. Because if you have learned at university, even if you passed njengamadoda score 50%, yeah, baba, you know the 50%ers are strange. When they get to work, man, they become the best you can find because they pay attention. They make sure they understand what they're dealing with, and they're the most likely successful in solving the problem, especially when it comes to doctors. And they actually make the best of specialists because they are careful, they pay attention, they don't come with this grandiose delusion that they master things and so they know, and they go around with their big heads but not really amounting to much. But you look at the high flyers, I'm not saying all high flyers don't do well, but most, they are a nightmare. They don't complete their jobs. Patients are running around crying. I've been seeing the specialist, no help, and that one just did a biopsy. He doesn't take out the tumor in the brain, okay? Because he's scared he's going to damage you. And when you get damaged, guess what? You're going to sue him. And he's not ready to have that happen because, you know what? They're so used to having it easy. They don't know when the going gets hard, you still need to walk the walk and talk the talk and come out victorious at the end. So at the end of the day, guys, however you do your work determines the quality that you're going to become. And sadly, it affects you so badly out there because right in the jungle, man, there's no distinction and just a madoda score. There's individuals who can take the tasks given to them and run with them. And remember, real life situations are not standardized exam at university or in high school. They throw in the punches as hard as a higher grade question. If you're not well aware, you're always going to lose and you're going to have a bad name. Your peers are going to laugh at you. You're going to be depressed because you will see that you're left behind now when it matters the most. Remember, there in real life, it matters what you can do and what you can get. It's not about marks. So please, guys, as much as you can, score high because it's very important to be motivated to score high marks because, I mean, for metric, there's no excuse. Less marks mean you're not going to get to the right careers that you probably want. So this is important. Marks actually have a meaning here. A distinction has a meaning because it puts you where you want to be. But at university, it's okay. It means you can be recommended easily for certain places, of work. Because if you have a very good recommendation from your professor, that means you stand a very good chance of being hired. But be very careful because you'll be hired with the impression that you are the smartest. You are the best. And when the test of time and life gives you the hard stones, you fail and you fail badly, then you're blacklisting yourself for the rest of your life because they'll be like, oh, this one was recommended highly, but he's a flop. So please don't waste your time on that person. Do you see? But if you came in and you had to grind your way up, as you go up, you will never go down. So be careful, guys. Get your distinctions. Yes, it's okay. But make sure you are a true representative of those distinctions. You did not just go through standard exams, crammed your way through, used your past exam question papers to answer the questions that are potentially coming, but you have not learned anything. That's sad. And this is what we see in the country. That's why we're not moving forward. We have a lot of graduates, PhDs, diplomas, honors, masters. But look at the state of our nation, guys. It's not progressing. And that's what I worry about. We're graduating a lot of people, but they have less impact on our societal situation. And that's not right. When we graduate people, we should see the difference. You can't be a PhD holder on just academic standpoint. That PhD must translate to some solutions in real life situations. And we must see transformations as a result. You just can't do an academic exercise and wear a red gown, but it amounts to nothing. You've not written a single textbook that perhaps enhances knowledge and learning in the subject in which you got your PhD, perhaps, maybe. You haven't. You're not even an author in some common journals. And that means you're not a game changer. You're a waste of time with your PhD. So please, guys, don't just acquire accolades that don't mean anything for the rest of society. Acquire accolades so that when we look at you and we call you prof, we know that this is a real professor. A professor is someone who knows their subject matter beyond, just common knowledge, beyond a common exercise at university. These are people who actually see beyond what they did. That is why they become inventors. That is why they become creators. That is why they are the game changers. Okay? And obviously, guys, I'm not negatively influencing you to just sit down and not do anything. But remember, if you're going to do something, you better just do it. And doing it means excellence. And excellence at university is not a true reflection of the marks you get. If you can just pass, for me, that's good enough because you are going to be effective. If you are a high flyer, I get worried because my question is, how are you a high flyer? Of course, there are true high flyers that you can see if you put them to the test, you subject them to some higher order exam, because usually when they're going to give you a cum laude anyway at university, you don't just get a cum laude for passing the standard exams. Your standard exams actually make you to be recommended for an extra exam for a distinction pass, because we can't just give a distinction to standard people. No ways. So at least for that reason, usually cum laude students have been recommended for an extra exam that is at the level of a distinction, so that we can say this candidate is distinguished. It's not just standard stuff and then we say you are distinguished. No. If you can gobble up standards, it's okay. It means ungugimba we standards. Abanye bayacegisa, bayahlanya ke abo, because why are they not eating? Don't they want to grow? But then we give you a special diet. Now, if you can chow that one and finish it, then we know we have a problem solver. Anyway, guys, that was just a little break. Sometimes I talk too much. Obviously, I infuriate other people who don't like the truth, of course, because if you find yourself getting worked up by what I just said, just realize you are in denial, okay? That means you're not ready to face reality. So just worry about your position rather than worry about mine. But of course, I can be a little obnoxious. I know. Please don't pay too much attention to what I say besides the subject matter, because you can find yourself misled or actually rubbed the wrong way, and that's not my intention. My intention is just to highlight a few issues that are not often highlighted because we often ignore those. And as a result, we end up not knowing why certain problems never go away. And yet, we think we are doing enough in attempting to solve them. Just a moment. Okay guys, so now it says write down the coordinates of A. See, question said write down. Now we already explored it, so we don't worry about anything. So we know that A is 30 degrees and 1. Easy 2 marks, guys, for the X and Y. Of course, if you didn't know, what must you do? You work it out. You should know that if this is the turning point, this is the maximum. And then the maximum is the 1 there from the amplitude. So if you know one coordinate, you can just take the equation. Say here G of X is cos of X minus 30 degrees. Then this implies that with this point A here, we've got X is to 1, such that 1 is equal to cos of X minus 30 degrees. This implies that cos of X minus 30 degrees is equal to 1. Then we go and say, this implies that X minus 30 degrees is equal to arc cos of 1. This implies that X minus 30 degrees is equal to, now what is arc cos of 1? Arc cos of 1 is 0, yeah. Arc cos, yeah, algebra kufuneka ibe strong, okay guys. Izathi ngu-0, so this is 0. We know that cos is 1 is 0, standard style. Standard style in the first quadrant, okay? So, what do we see? Therefore, X at A is nothing but 30 degrees. You can say, therefore, A is 30 degrees is to 1. So there's many ways of killing a cat, but when the question says write down, it means this guy must be your RW. Okay, please learn to just write what is asked. Because should you write gibberish on top and end up with the right answer, you lose those 2 marks. And those are easy 2 marks, okay? But of course, use your algebraic ways when you feel like, okay, nothing is making sense by inspection, then just take it to algebra. Algebra is not going to throw you off as long as you are faithful to it. Write down the equation or equations of the asymptotes of y equals 10b of x plus 20 degrees for that interval. So now we need to be very careful. We have y equals 10b of x plus 20 degrees. This implies that y equals 10. We saw that this is a half, right? We saw the value of b was a half. Now we have what? X plus 20 degrees, so that's fine. So what does this mean? We are shifting this graph essentially 10 degrees, not 20. 10 degrees, because when we distribute this inside, we need to do that, by the way, so that we can understand. But now half of 20 is 10 degrees, so this is going to be 10 degrees to the right. So that means all these asymptotes are going to shift 10 degrees to the right. So this is going to shift 10 degrees to the right. That will be there. And that should shift 10 degrees to the right. It will be there. But now we are given a strict interval that this should be there. So now there's only one equation of the asymptote we're going to get. We're going to say, therefore, y is going to be, let's just write, therefore, asymptote of y is going to be such that x, remember the asymptote is a vertical line in this case, x is equal to 180 degrees minus 10 degrees, which is going to be equal to 170 degrees. Now again, the question said write down. So what does that mean, boys and girls? It simply means please present the answer only. Do not tell us how you worked it out, because should you write gibberish on top and then you end up with the correct answer, we will then know you copied and you're talking nonsense on top of that, and therefore we just not give you the mark, because it means you didn't generate this mark yourself. So don't show us that you are cheating along the way, because sometimes you may cheat in the right way and succeed, you see. So be very careful, guys. So you simplify that expression even further. You simplify that expression even further. I don't know. Should I write it? So this is 10 of half of x plus, now half of 20 is 10 degrees. So this is our angle. Now we can see that this is our original 10 function, but shifted 10 degrees to the left. And when we shift to the left, in actual facts, we then subtract on the actual coordinates, but on the function we add. So that is another thing. Be very careful of these signs. They will throw you around and make you a scrub lab. They'll make you a scrub lab. They will mop the floor on your face, Baba, or with your face. So please don't find yourself mopping the floors here, because can you see it's just one mark? It means you just needed to get a stat. Can you see though the thought process behind it? It's so hectic. So this means be able to look at this by inspection and see what happened and make a conclusion, or else chisampama. Dennis Lauter in the 18 area. Now determine the range of h of x if this is the case. Okay, h of x is basically 2 times g of x minus 1. This implies that h of x is 2 cos x minus 30 degrees minus 1. Now we know, folks, that essentially, we know that essentially the range is going to be maximum and minimum, and that comes from the amplitude. So the maximum and minimum is going to be 2 and minus 2. But then we have to consider this one for each of those. So we can say, therefore, the range is equal to a set of y values such that y, now we choose the minimum, is going to be minus 2 plus 1. Sorry, minus 2 minus 1. Sorry. Okay. What am I saying? Okay, masipale kanje. Y must be greater than. Okay. So we can say minus 2 minus 1 greater than y, which must be less than, in fact, or equal to. We take the positive 1 and then we subtract 1. And as we can see, this is an augmented graph vertically shifted down. Okay, so now we can already see here, guys, that this is already, maybe we can say implies, we can say therefore our range, and as it can say range y values such that this is minus 3 less than or equal to y greater than or equal to, or which one is also less than 1. So that's the answer. Again, guys, a question like this is just 2 marks. Learn to present the answer only, meaning all of that must be in your rough work, please. An answer only is safer here, but there's no harm in showing how you did it. But in any case, you still get a mark for that and that. So you get your nice 2 marks. Obviously, you can present this as an inequality, and that's it. Or you can present this as an interval notation, because y is an element of real numbers here, so it's acceptable. So I hope you guys understand and you can see what is cooking. So again, guys, we are taking these easy 7 marks and we are saying take it easy, boys and girls. It ain't that complicated. Okay, so that's it, guys. So if we have done everything accordingly, we are okay. Ne? But inhliziyo yami ithanda abantu abarongo. I'm worried about this one though. I have a debate in my mind. This one is forming a debate. The problem is that the angle is the one that's shifting, not necessarily the half. You see? Ingathi inhliziyo yami ithanda abantu abarongo apha and ayiva kudala isiwa kodwa ayifundi lutho. Siyitsho intokazi zakwaqwabe. Okay. Hey guys, yabona ngoku ikhona i-challenge anyana. Ifuna ukunifaka ko-May, June no-July. Andikho sure ke phayana. But here's the thing. Whose shifting is x, not the half. Yabo? Because remember, this was 10x. So the one that's shifting is the angle actually. It's not the coefficient. So the coefficient, nah. I think, guys, we are lying to each other here. But now, saying denza ke ngoku ndingaqiniseki. Jonga napha ke bantram. Ebomini, you are always forced to, reconsider your position sometimes. So maske sithi ngo-20 laphana. But again, izozijongela kwimemo andithi. Please, ngicela niyicheke le guys. Sekukhona i-doubt anyana in my mind. If, of course, you feel confused by what I just did, please ask your teacher to elaborate. If the memo is not doing that already. So the good thing is that there is a memo here. Yeah, let's just leave it here. There is a memo on this paper. So please do it. In fact, I will provide you this paper as a whole together with this memo down below. Then you can have a look at it. And if you scroll further down, usually with Stanmore Physics lately, they attach the memo down there. So you can have a look for it and prove if indeed what we are doing is making the sense. So yeah, that is the story. I'm not too sure about this one, folks. Sometimes these questions have a tendency to overwhelm the mind. So look for even replicas of this question like this and see how it was solved. Then you will get the right impression. Kiabilayela hona mona, wabona. Kinaleho belayela nyana. Hagiathaba handle. Wabona. Yeah, sometimes you don't know everything, guys. I also don't know everything, so be careful. I'm not Mr. Know-it-all. In the diagram, B, C, D, B, C, and D lie in the same horizontal plane. Usually, this one gets ndondons. So, masis shaded. Ingat be shady, we got a kaya chitek. Now, BD is equal to 2 times CD. So, CD, where to say simnigi ubangu X, go B, sorry. So, this means this one is 2 times B. Very important, guys, to look at statements and do the right interpretations. Now, CBD, the central business district for those who do geography equals X. Okay, it's shown. BCD equals Y, it's already shown. And CD is B units. Fine, we already transferred the knowledge. AB is a vertical tower. So it's already indicated. If this is vertical to that, remember this is the same horizontal plane. So this already means this is also 90 degrees too. So go 90 degrees, 90 degrees. So we must think of that, but let's just leave that for now. But that's the impression. Now the angle of elevation. Now elevation is from horizontal up. Of A from C is theta, also indicated. So everything is there. Remember, if none of what is shown here was indicated, you indicate it, okay, to make it easy to solve. Now let's move on. So now we need to show that sine y is equal to 2 sine x. Okay, so this is just 2 marks. Not a problem. So how do we prove this, guys? Well, this simply means we're just going to use our sine rule here, because we've got the angle opposite side, we've got the angle opposite side. So we're just working on that triangle. Usually the triangle where you have two angles at least and a side given, it's usually the triangle to start with to prove the big one like that. So already we're starting, someone is just pushing us into the very same issue. And of course, always calculate all possible angles in any triangle that you can see. So this is going to be 180 degrees minus the sum of x and y, isn't it? From three angles of a triangle. Good. And also that angle here, we know that it's going to be 90 degrees minus theta, again from sum of angles of that triangle. So all things that need to be done, please make sure that it's done. Understand your diagram, make it ready to work with. Then you start working. 7.1, let's do it. So we know that we want sine y, so we can just write in triangle BCD. What do we see there? We know that sine of angle C in that triangle over the side opposite it, which is going to be BD, must be equal to sine of that angle B. So sometimes you can just write them as angle B instead of the comprehensive angle. I don't know what's cooking. The sine of angle B over the sine CD. So now why are we doing this? We are using the sine rule in this particular triangle. So remember, in this triangle, these are the angle C's. There's no need to say D, B, C or whatever. Now we just substitute. What is sine C? It's sine of y divided by BD is twice side B. So this is sine X divided by just B. Holy cross. Now obviously here we just cross multiply there because we want to isolate sine y. So sine y is going to be 2b sine x over b. Now the b's do the b things and get out of the way, which leaves us 2 sine x, and that's it. Nice and easy. So how do we score the 2 marks? Obviously the answer was given. So the most important, folks, is to set up the sine rule. Nice and easy, and then do the substitutions. This is what matters. The rest of the gymnastics is your problem. Or maybe not even there. One can get a mark here. That's fine. Either way, it makes life sensible. So 7.2. Now we need to do this. Now AB, you can see this is this side. So it's in the other triangle. So this means we need to see what is common between this triangle and that triangle. Let's put asterisks. What is common is this side right here. So always use common sides to cross over. Use a bridge to cross a river. Don't just cross the river. You will die. Use the bridge. There's always a place to cross. Now, what we need to do is to find BC. That's literally what we need to do. But now, how will we find BC? And as you can see, there's that XY and that XY. Can you see? There it is. So this already tells you and I, if we see a square root sign, we must have squared things. That means cosine rule here, because there's this angle. See the cos of that angle. That means cosine rule in this triangle was used. So you can even look at the expression and get an understanding of what happened. The tangent of theta is only going to be this side, that side, the opposite side, over the adjacent when we say tan of C, and that will help us to find that angle. So we know that the tan theta comes from using the tangent in that triangle. So we already know where we're working, so we just work. Now we're going to start and say here, fine. Now I can just throw in the cosine rule, nice and easy. In fact, what I do, I like to just use my reference triangle and say in triangle, say A, B, C. Okay, now I want the side BC in this triangle, but now I'm going to use the other triangle. So what do I say? I will say BC squared is equal to, say BD squared plus CD squared minus 2 BD CD cos of angle D. Now you have to specify what did you do just now. You can say the cosine rule in triangle BCD. Now I have to specify the triangle because now I'm using this triangle as a means to an end because I'm trying to get BC in this triangle so that my work is smooth. So have a nice work ethic, guys. So BC squared equals, now BD is basically 2B squared plus B squared minus 2 into 2B into B cos of that angle. Angle D there, we can see in that triangle. It's going to be 180 degrees minus the sum of x plus y. Okay, now this can be a bit challenging because now how did we justify this? That angle D is like this. I mean, it's sum of angles in a triangle. Do we really have to provide a reason there? Not necessarily. So we can leave it at that. Okay. Now, we simplify further. So we've got BC squared equals, this is 4B squared plus B squared minus, this is going to be 4B squared cos of 180 degrees minus the sum of x and y. Okay, nice and easy. Now we just take our time. Don't rush it. It's going to be messed up. You add the like terms. This is 5B squared minus 4B squared. Now into minus cos of the angle now. This is x plus y. We're doing reduction formulae. Nice and easy. And then we keep working our magic, guys. We know that BC squared is going to be equal to 5B squared minus 4B squared. Now times, when we simplify this, the sign changes to just cos of x plus y. Now we are good because now we do the gymnastic of choice, square root everything. We square root everything. My brother, from another mother. So this is BC is equal to the square root of, now we can factorize here. B squared is common. Now what is left inside is 5 plus 4 cos x plus y. Nice and easy. Now we do the final gymnastic. We know that the square root of b squared, remember once you multiply, that b comes out, but now this one is irrational at the moment, so we take it out as it is. 5 plus 4 cos of x plus y. Akuyiyo lanto injengoba injalo. All right, now remember guys, this is not done. Okay, I'm saying the excited. This is BC. This is not AB. Now we wanted BC in this triangle because we sebenzisa as a means to an end. Now we simply say here, then we're still talking about that triangle. We know that 10 of, maybe let's say ACB is equal to the opposite side, it's AB, over the adjacent side, which is BC. Great. So what is this? We simplify 10 theta is equal to AB, what we want, over this dude, B square root of 5 plus 4 cos of x plus y. Now this is over 1. So we cross multiply there to isolate our AB. Therefore, AB is going to be equal to, now you can see here B was put in front times tan theta times the square root of 5 plus 4 cos of x plus y, 100%. So these questions, guys, are easy. It's nothing but three-step approach, applying BODMAS, factorizations, identities, and use the doctor's approach as an overall, meaning understand the problem first, get it right, know that this is the test I need to run, confirm those, and you have a diagnosis, or even worse, treatment. All right? Or even better, not worse, treatment, because a diagnosis without treatment is horrible, isn't it? Because you tell someone they might die from something that you cannot help them with. It's really bad, isn't it? Really bad. It's like a doctor who goes and investigates an inoperable lesion. I can see where in the brain this thing is sitting. I cannot operate. And from the characteristics on the CT scan, I already know this is a glioblastoma. Now there's no bloody treatment for that thing currently. It's just deadly. Then you'll find a doctor going to do a biopsy there, confirm that it's GBM. Then they will tell you, we will give you radiation and chemotherapy, maybe a temozolomide, and you only have 8 months to survive. Can you believe it? Yes, it sounds right, because culturally overseas, patients would like to know when they're going to die so that they can start sorting their wills, spend as much time. Unfortunately, we are different traditionally. If you tell me I'm going to die, you have already killed me before my actual death. I will just lock and not know what to do. I'll be miserable and die before that time comes, if I'm lucky. But here's the thing. Do you then say, you don't have anything on the brain, it's nothing, we can treat it, and then you end up dead? But which death is sweeter, guys? The one that you know I'm dying, or the one you don't know you are dying? Yeah, then comes the ethics, isn't it? Now, what governs what actions do you take as a person? So obviously, ethics play a different ball game, and you can see ethics as a whole, they were not built on the African perspective of things. They were built on the European perspective of things, or the Western perspective of things, because people want to know. Now we end up telling our folks, yeah, you have 6 months, and man, you look at that person, you just know you've broken their spirit. Well, since our societies are being westernized, civilization, we're losing touch with our backgrounds, with our ancestors, with our roots. So maybe it becomes appropriate now, because people want to know everything, even what is not helping them. So maybe it's okay. But I always get thrown into the deep end when I have to tell somebody they have something we cannot help with. You see, we see these children sometimes around 12, 13, maybe 8, the lowest age. Then maximum up to 13, 14 years of age, usually girls. They get these bad brainstem gliomas, these diffused tumors on the brainstem. And the brainstem is the seat of life. This is where your breathing is eventually controlled. This is where your final transformer to your lungs or diaphragm is sitting. Now, if you impair that, that means the will to breathe gets gone. Again, the bulbar part of the brainstem, which is the medulla oblongata, this is where your seat for the cardiovascular system is, meaning the lower pons and the rest of the medulla oblongata. There's nuclei there that connect with the hypothalamus, which is the actual, power station of these autonomic nervous systems. Now, what happens is you're sitting there, now there's compression of that part because of this diffuse glioma. It impairs all those nuclei and the connections. That also means your cardiovascular system is going to collapse and it's going to be difficult to support even. Now that means you're going to die, okay? Now you look at these girls when they come, they just have what we call raised intracranial pressure, hydrocephalus, because of obstruction of the aqueduct of Sylvius by this tumor mass, meaning CSF doesn't come out of the lateral ventricles and the third ventricles into the fourth so that it can exit at the exit foramina of Magendie and Luschka into the subarachnoid place so that this can go back at the level of the granulations over the sagittal sinuses and the transverse sinuses so that that goes back into the blood, back into the heart, and the circulation continues. Ish man, yabona ndikufundisa human physiology. Yawen, and that's why, but I say sugile lendab. Now, when those people come like that, if you put a shunt to divert the CSF, so we operate and put a shunt, and then the kid is alive now, is able to eat and swallow, because the symptoms are not because of the destruction of the brainstem nuclei and connections. It was just purely because of pressure-related issues. Now you've addressed that, then the kid is okay, is smiling and laughing and eating. But I know, guys, within 8 months, that kid is not going to be able to move. He's not going to be able to eat. Not going to be able to swallow. They will aspirate, meaning saliva or food is just going to go into the airway because there's no coordination once you lose the functioning of the medulla. You know that the vagus nerve comes from the medulla, and that helps you to swallow. Now the swallow is incoordinated. That means you will aspirate. You will get pneumonias, you will be in hospital, you'll be stiff, unable to walk or move. The joints become deformed with contractures, and that person dies a very sad death, man. And you're like sitting there and thinking, when I say this, do I tell the parents this is where we're going to go? Or do I tell them, okay, it's fine, we will see whatever when it comes, and then explain it then? When you tell them that time that actually there's a tumor, you look like a liar. That doctor lied to us, didn't tell us the whole truth. You tell them the truth, you make them look at their child and see their death before it comes. Do you see how very difficult this thing is? So ethics is a rough situation, guys. It's not forgiving. But anyway, this is just me sharing some of the difficulties of becoming a doctor in our African perspective. And yet we are trained in the Western perspective of things. And unfortunately, the results of these things, or the consequences, are totally different. So now, what do you do? What do you do? So guys, don't be excited. I'm going to become a doctor. Oh man, it's difficult work, believe me. As gratifying as it is in the most cases, where you see someone in trouble and then you can treat them and then they go home smiling and you feel you've done something good. But comes those moments where not even your best of knowledge and ability can save the day. It only creates pain and mayhem for the families. Sometimes you wonder, should I even intervene? Should I even drain the CSF and let the patient just, die from high pressure already? Because at that time, their level of consciousness dwindles anyway. They are not aware of what's cooking. Isn't it better that way than to actually drain that thing and then they suffer from brainstem issues? If they are still fully conscious, they are aware of what is cooking. Isn't it that torture? Where I'm awake and aware, but I can't do anything. I don't know, guys, but yeah, medicine can be sad. Can be very sad. Because you see someone's death before it even comes. And if you're looking at that innocent soul, you're like, goodness, this one doesn't even know. Because you can talk to parents on the side and spare the child or whoever is the patient. But the reality is, when you look them in their eyes, you're like, my goodness. So yeah, folks, certain things are a nightmare. But anyway, whether they are a nightmare or not, somebody has got to do that part of the job, isn't it? That's what we signed up for. Those of us who became doctors and those of you who are going to become doctors. it's not a smooth say. As gratifying as it is, it can break your spirit as well. Because how often are you going to cry when someone dies in your hands? How often are you going to cry when you see someone die because you can't help them? How often are you going to cry when you make a mistake and it's deadly? Somebody dies. What happens when you overlook a blood result and then that results with someone dying, or you don't do it on time and then someone dies? So how often do you take the blame? How often do you cry about it? So what motivates you going forward? It's rough, eh? It's rough stuff. But here's the joy to it. Even in the midst of the storm, if you can stand tall and be unshaken, I believe you will see yourself as a victor, because it means you can prevail despite the circumstances, because it's not always stormy, isn't it? Sometimes it's sunny and calm. Sometimes it's cold but not dangerous. Sometimes it's warm and moist and humid, and there's a rain. There's a potential for danger if the thunderstorms are out of control. But there's also a big gain if the plants are going to grow because of the rain. So at the end of the day, you're like, holy cross. Life, man, is just a challenge, and we need to take it as such and never accustom ourselves with the softer parts of life. Also have a spot in your heart, in your brain, in your mind, in your whatever, for some rough patches on the earth, and please prevail through those rough patches, because there's more joy than sadness if you live like that. Even a sad situation is not going to be heartbreaking for you. You'll know it's part of life, and that means you can still have joy despite unhappiness. Joy is something else. It's not happiness, guys. So please look for joy. And as you can see, there's a song that says, it says, I have joy, peace, and happiness in my soul. But as you can see, joy is more important, because even when the peace disappears, even when the happiness goes away, if there's joy, you will go on. Hi guys, let's not motivate you now. This is not a motivational talk, man. It's mathematics. So hey, let's do the mathematics. Sometimes ndiyadinwa wethu guys kukusebenza. So I start talking, then I lose myself in the talking because I talk too much, you see. Ndingabantu abaqevutha kakhulu. Asiye ke ngo 7 marks zisuka phi bantram. This angle there that we calculated is a mark on its own. You see most, and that one, knowing that it's going to be 2b, it's a mark on its own. You see most, and then the rest of the situation is the mark, and the final mark comes here. So can you see 4 marks in just one step? That was probably not so significant. Yeah, yikes. We'll still see what to do about the rest of it, you see. Yeah. Now, we defined the tangent in that triangle, so that's fine. And then the substitutions, they look okay. Now, obviously, guys, we've got a mark there. This one was already volunteered. Do we really get a mark for it? Maybe, maybe not. We'll see. But now, where is the situation? We have how many marks so far? 1, 2, 3, 4, 5. We need 2 more marks. So what do? Well, we can say the gymnastic of taking the square root. Sounds fair. You see, here we can award a mark. This is still algebra. That's the 6th. And then we need to find the 7th mark. Maybe to define 10 in this triangle, because now this answers the question. We can give a mark there, or we can give a mark for our cosine rule. It doesn't matter, whichever you choose, you can give a mark. For me, even the gymnastic is just part of the game. Maybe we can say, nah, there's no mark for the gymnastic. But maybe there's a mark for the rule on both occasions. So this is 1, 2, 3, 4, 5, 6, 7. So we've got our 7 marks nicely. But again, you can look at the marking guidelines that are official, and you will see where those marks are. But again, pay attention to the method used, because different methods will be marked differently. Hence, determine the height of the tower, rounded off. Now this is usually the easier one. Again, it just deflates the pressure. Now we have everything that we want. So we know that AB is equal to, now we're told B is 5, 4, So this is 54,8 into 10. Now we're told the angle. So, ish guys, I don't know, my throat is doing things. Now we know that this is 10 of theta. Now theta is 42,6 degrees into the square root. So a whole lot of such substitutions. This is 5 plus 4 cos of this angle. Now x plus y, this is 31, or just 31. So this is 31 degrees plus y, 75,84 degrees. So there's a whole lot of substitutions, folks. Now you just need to punch it in the calculator and please write us a correct answer. So make sure the substitutions are careful. So we start by saying 54,8 into 10, but be very careful here of how you write this. 10 of 42,6. Now we need double brackets there so that we can have the big bracket outside, and then we say again into, then we put the square root sign. We've got 5 plus 4 into cos of these ones. We write them as they show up. 31. Oops. Got 31 plus 75,84. Then we close that bracket and we close it again. And we go outside and close the big one. So if you don't do that, this is 98. Now to 2 decimal places, as indicated here, is 76 meters. Is it meters? Let's see. Yes, they said this was b meters. So that is meters. So be very careful of the unit of the final answer. It's very important. Okay. Easy, ne? Yeah, very easy. So this is just to test whether you know how to use your calculator well. But I feel like this is tautology. We already told us in the general instructions. So I wish they could just leave you here to do the right thing, so that if you don't do it, you lose that mark. Okay? I'm cruel, guys. So I have to be CMOS. So we get a mark for that. So this is 2 marks. Okay? Again, when the question said hence determine, even an answer only can get 2 marks. Okay? So this was a rather okay-ish 11 marks, but we know that 7.2 was a bit of a country mile, isn't it? It's a simultaneous equation thing, so it's always going to be a bit more demanding. Okay, we are done here. We go to our favorite, Euclidean geometry. I have enough space here. I can start this question here. Now, Euclidean is my favorite because it really challenges your mind. This one is a naughty boy, or it's a naughty girl. Maybe we can say it's a naughty boy or a feisty girl. Very appealing, but very challenging, because you can never say you know it. No, you can't. No matter what strategies you can bring forth, you can just get the most of it, but not really all of it, is it? I think so. Anyway, whatever I think, it's immaterial. In the diagram, A, C, E, and G are points on the circumference. So what we call points on the circumference? Concyclic. Meaning there's a circle around those points. And we see it. There they are. So what does that mean? It means, this means A, C, E, G is a cyclic quad, because those 4 points make up a cyclic quad. Okay, but be careful, sometimes they may not make up a cyclic quad, but either way they give us a cyclic quadrilateral vibes. Any 4 that form a full quadrilateral, that quadrilateral becomes a cyclic quad. So this is another way of saying that is a cyclic quad. Now, okay, circle, center O. So if this is center O, then it means these are ready. And we know ready are equal. And if these are ready, then that already says UE2 is equal to UE1. We know that these are angles opposite equal sides in a triangle. So that's nice. Can you see? We are moving. Just given a piece of information, there we are. And if this is 36 as it is given here, we can easily determine the actual sizes of C1 and C2. Now we're told here DFE is a tangent. Now an angle between the tangent and the chord is going to be equal to the angle subtended by that tangent. By that chord at circumference. And we can see this one does not subtend anything at circumference. Now we change the ball game and say, okay, fine, that one is best to ignore. But what about the angle between the tangent and the chord in this manner? So this will be equal to the angle subtended by that whatever at circumference. So can you see that angle as a whole speaks to the tan chord theorem. So there's a lot to consider, guys. So we just keep doing what we can do. Then we leave it there. Again, this is the center going to the tangent. It means these angles are all complementary angles. What do you know about complementary angles? They add up to 90 degrees. Now, we can see that this line is drawn parallel to that line. So if this angle E3, 4, and 5 makes up 90 degrees, it means B2 should be also 90 degrees, right? Right. Why? Because co-interior angles are supplementary. So if this is 90, obviously the partner is going to be 90 as well. So that's very good. So we can see, and now if this is 90, a line from center perpendicular to chord does what? Bisects the chord. Yeah, when? Do you see, guys? Do you see, guys? Then if you just deal with the problem by understanding it, you are done. Now let's see. We are told here that DF is parallel to CA. Yeah. BOE is a straight line. Cool. BOE is a straight line. Not a problem. This is just to suggest that this is a transversal line so that we have co-interior angles. Remember, for this to be co-interior angles, this has to be a straight line. So that's the essence of that statement. Okay. With B on point Dantoni and A is drawn here. AC is 14 units. So can you see the stories right here? So this is 14 units. So if this is 14 units, already we can see now the question is going to be either on AB or CB, but we'll use this property to say line from center perpendicular to chord bisects the chord. So this is already giving you enough weapons to deal with this problem smoothly. Let's start with the questions now and not waste time. Even here, we can see that this angle at center, for example, this is the angle at center. An angle at center is twice the angle at circumference. So we can even get the value of A1. Excellent stuff. So let's start answering. Obviously, do enough, not too much, to be able to proceed. Now we're told to calculate with the reasons the size of each of the following. Can you see A1? So we know that obviously 2 times angle A1 is equal to angle COE. Why? We know that angle at center equals 2 times angle at circumference. So we can say at circle. Nice and easy. So this implies that 2 times angle A1 is equal to 136 degrees. Therefore, angle A1 is 136 degrees over 2, which is equal to 136 kanene ngibani. Hayi, ndingazisokolisa. Kutheni ndizazisokolisa? It's 68 degrees. Guys, don't just jump to answers. Be systematic. Do not find yourself here. The question said calculate. Now, what does the instruction say? Show all the workings in your calculations. Everything you've used in determining your answer in any calculations, please show us. Now, there's many of you who just come up with the statement that angle A is 68 and then write that reason. That's rubbish, actually. I'm sorry to burst your bubble, but that's nonsense, and you should be marked down for it. But obviously, the markers, because these are marked in your districts anyway, so most likely some of your teachers are there, they'll be lenient to you. But actually, they should take you down because you're not following instructions. Remember, the exam is not just the answers. It's actually following instructions. So it's very important. When the question stipulates a calculation, we need to see a calculation. Should we not see it, then you didn't do it. You can't do this by inspection. We said calculate. We didn't say determine. A determination can be done by any means necessary. But once we specify how we want our answer, please give us the answer how we want it. Show all the steps as per the instructions. And get us to the answer. Because we're not just interested in the answer. We want the whole thing. Obviously, this statement and reason and the answer is 2 marks. But you can't just write those two only. This has to show. This is where certain things become important. As you can see, I highlight where it's not necessary. And I highlight where it's necessary because you need to answer the question accordingly. Don't answer your own things. Please, guys. This is very important. Now, what is angle E1? Now, angle E1, if we look at it, it's actually 10 chord. How did I miss this one? This is the angle between the tangent and the chord is equal to the angle subtended by that chord, which is A1. Sometimes, of course, you're not going to be complete, obviously. You may have to look again. So we know that angle E1 is equal to angle A1. Ne? Provide a reason. This is because of the 10 chord theorem. And again, be careful of the notation of writing the reason. It's key. You don't just write it however you want. If you're going to write it in short, of course. Now, make a conclusion. This is essentially 68 degrees as well. Please refrain from, just not being systematic. Mawube clean umsebenzi wakho mntwana wesikolo. So that's a mark. In fact, the 68 is not necessarily a mark per se, but the mark is actually the statement and reason, because this is already taken from above. So there's not necessarily a mark on the 68, but it has to be stated because the question was find the size of that angle. Anyway, BCE. BCE. Can you see we want that angle? Now we have to do a very smart thing. I mean, it's just 2 marks, guys. So what does that mean? Now we need to realize something. If we can just change our stories a little bit, we will notice something. That actually, this very angle A1 is actually equal to that angle there. We can actually remove this mark, the black mark. We can remove the black mark. I don't know why. This is actually equal to that angle. Why? These are alternate angles. Can you see this is parallel lines and the transversal line? So those are alternate angles. They are equal. But then this one is the angle between the tangent and the chord. So can you see? So now, once you see things, you can even refine your diagram better. So can you see this angle is equal to that angle? But now the link is a bit indirect, if you think about it. The link is a little bit indirect. Or we did not even need to come down here. We can actually use alternate angles right there. Still the same alternate angles. If we know this one, it alternates with that. See, the 2 marks already tells us that we don't need a third angle to link, but just directly. Okay, not a problem. So we can just write the angle there, BCE is equal to angle E1. Why? These are alternate angles. State the parallel lines with AC parallel to DF. Okay? So make a conclusion. Therefore, BCE is equal to 68 degrees. Nice. Always answer the question. But when you put statements, please avoid having more than one equal sign. It's ridiculous. Doesn't look sightly. Doesn't look like maths. Again, the mark is not necessarily on the answer here. The mark is on the statement and the reason. That's the most important. But we can distribute the marks according to everything because, again, the question was on the size. So sometimes be very careful of how you answer. Are you even answering the question asked? G. Now you can see G is doing its own things now. How do we find G? I don't know why. Oh, 2 marks. No, that's not the one. 2 marks. Okay, good. Because I was like, yeah, this is crazy. Can you see? This is a cyclic quad. So that statement that these 4 points are concyclic works in our favor now. So we know that angle G plus angle, let's say ACE, is going to be equal to, maybe let's not introduce a new term. We spoke about BCE, let's just call it that, plus angle BCE is equal to 180 degrees. Why? These are opposite angles of cyclic quad. Obviously here the cyclic quad, there's only one there, so we can leave that without specifying, but if you like you can say it's ACEG. Now this implies, remember the question said calculate. So when there's a calculation you need to see it, but some questions like these ones don't provide as much. So we just go with the determination. So this is angle G plus 68 degrees is equal to 180 degrees. Therefore, angle G is equal to, please don't write G. The G must have a cap either at the top or before. There has to be that notation to show that you're talking about an angle. If you're not doing that, I'm taking you down, students. I am taking you down, and it's going to feel like I have, a special hate for you, but you actually are the one who is asking, not asking. You're actually asking for my hatred because you're insulting my maths. If you're going to write it like a hooligan, maths is not for common people. Okay? It's for serious people. It's not for plebeians. It's for konje kwakuthiwa zii-plebeians nantoni phaa kuJulius Caesar abantu. There's plebeians, which are the common people. And then kuthiwa zintoni kanye nabantu aba-rich who are affluent. I forgot. So this maths is not for plebeians, guys. Plebeians do maths literacy. Okay, I'm joking. Hey, ningandibulali. I'm sure beseni-ready ngezikere zokunisika. No, guys, you can't cut me. Eh? You are not cutting me. I'm just joking, you see, Mos. I like to play with you. Maths lit is difficult. If you looked at it, it's actually as hard as pure maths. There are some questions, they just show you that indeed that thing is not a walk in the park. I don't know why people go to it and leave pure maths. Rather do the proper thing, the complete thing. Maths lit just gives you glimpses of real maths, but the rest, it's common to everyone. But the level of examinations there, it's almost a pure maths level. Although they make it easy by providing certain things, so it's okay, whatever. But be very careful, maths lit is a killer. It's a low-key, dangerous murderer. It's a serial killer. I don't know how many people have failed Maths Lit, and yet it was meant to be easy. It just proves it's not easy. It's not that easy. Calculate where there is the length of AB. Can you see? Now we have to speak and speak and speak. And on top of that, we must show a calculation eventually. So here, this is a question that will complex a determination with a calculation. And it needs to come out because for these 5 marks, we need to show it. So what are we going to say? Well, we are going to say, number 1, we know without a shadow of doubt that this angle here, we can call it BEF, is 90 degrees. Why? The tangent is perpendicular to radius. Nice. We can say now, this implies, when we say something, it takes us somewhere. And remember, the question said calculate, so we need to show a calculation now. This implies that BEF plus angle B2, we must see 180 degrees. Why? These are co-interior angles. We always state the parallel lines. AC is parallel to DF. That was given. That's why we know now they are co-interior angles. Then we show our calculation. This is 90 degrees plus angle B2 is equal to 180 degrees. Therefore, our angle B2 is 90, superb. 180 degrees minus 90 degrees, which is going to be 90 degrees. Now, we are at liberty to do the final thing. We can say, well, if that's the case, we can say then, what do we know? We know that we want AB. We can say, then we know, so okay, maybe let's put it this way. Say, if that's the case, we can also make a conclusion, therefore, that actually AB is equal to BC. Ne? Why? We know that this is the line from center. This is a line from center perpendicular to chord. It actually bisects the chord. That's beautiful. We can say then, we know that now 2 times AB is equal to CA or AC. That's quite easy now to go about it. So we know that 2 times AB is equal to 14 units. Therefore, AB is 14 divided by 2, which is equal to 7 units. Remember, guys, the question said calculate, so you can't just show up with this one being this and then you just provide that reason. Hey, I am warning you guys. You don't want to lose marks over stupidity and yet you've got the right idea. Please take it to the end. Don't be complacent. This is key information. And that is also key information. And that is key information. Right? Right. And this is also key information. Can you see 4 marks? Nicely. Nicely. And now all we had to do was to just find the final answer. Nice and easy. So these were some easy 13 marks, with the last one a bit naughty, but nothing out of the ordinary. A math student would know how to chew upon that one. Nice, 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 nice. I see you again, guys. You've got a memo here. So you will be able to scroll and prove if what I showed you is right or wrong, okay? I usually do not waste my time looking at memos when I can use my brain. I trust this thing inside my skull And I don't care to be wrong. I'm not afraid to be wrong, by the way. So you may even want to say that's ignorance, but it's just because being wrong is natural. So it doesn't make me afraid. I'm not afraid to be wrong, guys. And you should also not be. So that you cannot be weak at approaching tough things because you're afraid you can be wrong about them. Just go for them. Because part of not being afraid of being wrong, it means you're not going to shy away from attempting challenging things. And that's what we need. So anyway, ditch that fear or keep it. It's up to you. In the diagram, triangle QRS. QRS is a triangle with RS produced, okay, to P. So this already says we have a straight line there, but it looks angled here. Let's prove it is not. See, it's definitely not a straight line, but it's fine. But this is what we're being told. If that is produced, it means that's a straight line. Okay. Now, U and V are points on QR such that PU is equal to SV. Sorry, it's parallel to SV, and that's already indicated. And I mean, if you look at this diagram, think of the question in 2022. Although they used a bit of a parallelogram there, but this is similar stuff to that. You know, it's similar. So be very careful. Practice these past exam question papers adequately, but don't just go through them. Understand everything you've done. There's no point in rushing doing those papers. Just do those papers properly. And the best way is to target sections. You know, if you're doing Euclidean geometry, do Euclidean geometry. Sit on it. Enjoy it. When you are satisfied you've explored all your options, look at the memorandum and see what options they have explored. Then you go trigonometry. Do your thing. Explore all options. Look at the memo. And then again and again and again. And then until you are done. Then you take another paper after that. Take a break, eat, do whatever. Come back, take another paper. Same method. But don't leave that paper not done. And again, don't just do Euclidean and stop and then you study something else. If you are doing papers now for your finals, take a day for maths. The next day must be for something else. So that means from 8 till around 10, you must actually try to do the most of the major topics systematically. Maybe do 2 papers and then come back in the afternoon from your tea break, maybe an hour. You do your thing and then you go into lunch and then you come back and do your thing. That means in the day you will have finished 3 papers successfully and completely with understanding included. When you need to refer to your notes, don't cheat yourself. Don't try to go by the head. Take your notes. Do an open book. Remember, this is an open book test. It's not a closed book test. But when you need a concept, bring it and apply it. Because if you start applying it, you won't forget using it again. You know? Do that thing. At the end of the day, you know that, okay, I have finished practicing paper 2 properly. Now, if that is, say, by the end of the day, it's around 5 or 7, you can then go for your dinner or your supper, whatever you call it. Then you come back, you take one last paper, you do it from the beginning to the end. Okay? Now, this is you simulating an exam now. Because remember, you're preparing for the exam. You need to keep time. But remember, when you're trying to build your courage, you build your strength, you're building your revision to be enough, you don't time yourself. You just do as you need to. But make sure you finish within reasonable time. That's all. But now at the end, maybe from 9 o'clock until 11 or 12 midnight, because there's no time to waste, guys. You must even go to midnight, but don't go over midnight. Then you know that those 3 hours from 9 to 12, you're going to simulate an exam this time. Remember, all the concepts are fresh. The practice is fresh. You've just done it. You've used your notes as well. You made sure everything is on point. Now you're going to put it to practice. Obviously, you may not be able to keep the time, but make sure you've answered most of the questions and correctly so. Then you know you're done with your maths. Now the next day, you take your other subject that is challenging. You know what the paper is like. So target sections on the question papers now. Do it like the same way. 2 papers for the first session. Take a tea break. 2 papers for the next session, but you are going through those papers properly. You're not rushing yourself. You're also using your notes when you need to. Do that. Remember, that is called studying, guys. It's not a waste of time. Then at the end of that day, you take one last paper, you simulate an exam. That would be around 3 papers, if not 4. You simulate an exam, then you know you are done with that subject. Then you go to the next. I mean, in the period of 6 days, if you're doing 6 subjects, you are done. That means in 1 week, you will have reviewed your entire scope for your entire exams. All things included. Then you can jump around now using your timetable to study your areas of weakness, fortifying by doing some higher order questions in those areas, because you're already complete. Then when you feel like you can, just pull a paper and simulate an exam again of what you did so that you don't forget. And then you keep doing that. Do the work that you need to do. At the end, you simulate an exam like that, like that. Trust me. When you get to those finals, you're going to score straight A's, even A pluses. So you can surprise yourself. Obviously, I'm saying these things because this is what I used and it worked. So it's up to you though. You want to bow out of metric with distinction or not? Remember, distinctions for grade 12 actually matter. But for university, not that much. But it depends on what you want. Now let's answer this question. We are told here that PU intersects QS at T. Okay, nice. And then we're told QU, this guy right here, over UR, that dude right there, is 2 over 3. So this means this is 2A. So choose a variable here to keep this in proportion. Be careful, these are not units. So this is 2A. Then that is going to be 3A, okay? Please don't just write 2. You will die because you'll think those are units. No, it's not the case. And then we're told QT over TS. This is 5, so you can choose B to B, okay? Please choose different variables for different sides because this is the essence of what we're doing here. Makes life a lot easier. Okay, nice. Now we're told to calculate. See, calculate. Now we need to see a calculation. Giving reasons, the value of PS. Where is PS? PS is that line over there. Over SR. SR is that one over there. Okay, so we can see that, okay, all right, okay. What we can see is that this belongs to this triangle. Let me just show you the triangle that we are looking at in the face. Now, this is already saying we are looking at this triangle. So guys, it means our final answer has to come from that triangle. Right. But then this forces us, because you can see this is 6 marks. It's a lot of work. This forces us to look for this side here. What is going to be UV? And if we find UV, if we're using this triangle, we can, to some extent, perhaps, yeah, we will also be forced to find that side as well. So that's very easy. We can see that. But now where do we begin? What is going to give us what we want? It's this triangle. So can you see that triangle? Because we've got the proportionality of those sides, we can actually work out what that one is. Okay, in terms of A. That can give us that. And once we have that in terms of A, it's a simple calculation. We'll just say this minus that, it gives us that. And then we can use this triangle now that we shaded to answer the final question. So this is very easy, guys. So when you plan your attack properly, by knowing what you're dealing with and seeing how to structure it, it works magic. So let's start here and say in triangle. This is QSV. Okay. So what are we going to say there? We want this side. So our lives can be made very easy here. We can just choose this side over this side and then that side over that side. It's easy. We can just say UV or VU. Let's just say VU over. Now this side over that side, UQ, must be equal to that ST over TQ. Now why do we know this? This is the prop theorem. Always take the parallel sides with UT or TU parallel to SV. Okay, I never really pay attention to how I name things as long as they will translate to what is visible. Now we can substitute now. So we know that we're looking for VU over. Now we see that UQ is 2A. Please annotate your diagram so that when you talk about 2A, someone can see where that is. Sometimes you don't need to explain that. ST is 2B. Okay, so don't show up with 2B. You must have shown it in the diagram. Over TQ, that is 5B. Okay, as you can see, the B's do the B things and get out of the way. So we know that VU over 2A is basically just 2 over 5. Now we cross multiply that. We will see that VU is essentially 2 times 2 is going to be 4A over 5. So can you see this is in terms of A. Now we wanted to use that as a means to an end. So what does that mean? If we have that, now we go back and say, okay, fine, in triangle. Maybe let's say then, because now we're going to answer the question. Then, okay, let's just say in triangle R, or maybe let's just PRU. Pru. Now that's not what I just wanted to write. PRU. Again, proportionality theorem, but we need to be smart. We need to first showcase what? That the side RV. Can you see we've already found VU. Now we need to find RV. We can say here RV plus VU is equal to RU. That's evident on the sketch. We don't need to justify that. Now we see that RV is equal to, what is VU? VU is 4 over 5A equals RU is 3A. This implies that RV is going to be 3A over 1 minus 4 over 5A. Okay, now these are like terms. What do? We look for the common denominator, 5. 5 by 3, that's 15A minus 4A. We can say, therefore, our RV is equal to 15 minus 4 is 9. Okay, it's 11. So this is 11 over 5A. Now that we have our RV in terms of A, what do? We can say then, what do we know? We know that PS over SR should be equal to VU over VR. Doesn't really matter. RV and VR is the same thing. Again, what is the reason? Prop theorem. State the parallel sides SV parallel to PU. Nice and easy. We're still talking about that triangle. Now, It's time to substitute. So here we can just go about it nicely. VU is what? 5 over 4. So this is 5, as getting 4a over 5. Okay. Divided by this one, it's 11 over 5a. Maybe let's just say 11a because that's on the numerator. Nice. And then we see that this is 4a over 5. We flip this thing, it's going to be 5 over 11a. Now the a's do their own thing and the 5's do their own thing. So what do we have left here? We have 4 over 11. That's our answer. Easy, ne? Yeah, that was one of the essay type questions. Again, you can see this question is standalone, so it makes you sweat a bit. Obviously, that statement is key, and essentially the answer is most important here. And then obviously here, the most important is finding this guy. Then the statement again and reason in a different triangle. We can then say here the ratio is important and the substitutions. So 1, 2, 3, 4, 5, 6. So we've got our 6 marks, and that is it for that question. Nicely. Okay. Now let's do, guys, this is proving the similarity thing. So this question paper stops here. So I will stop here. I will not show you this, guys, because all you do is just do a construction. The highlight is to do a construction, and any construction must be a broken line. Now you construct, say for example, A, B, C, and then you can say E, F, you can say G, and H, so that AG is equal to ED or DE, and basically we use congruency here. But again, we'll prove it, and also that this angle, the angle is the same, isn't it? Because that is given here. So we can see that essentially this triangle here is going to be congruent to that triangle. By construction, of course. So by construction, that is the story. Now we will have to then prove that congruency first. It's going to be side, side, and an included angle. Then that proves congruency. And therefore, it will also conclude that this side is therefore equal to this side. Well, those are the corresponding sides of congruent triangles. But then, what does that mean? We know that this angle is equal to this angle. It is given. But now this angle will also be equal to that. Those are the corresponding angles of congruent triangles. So this means this angle is equal to that. And what does it conclude? It concludes that we have this line parallel to that. So if that is parallel to that, this is now because corresponding angles are equal. Now we see we've set up the proportionality theorem, and then you can make this conclusion using the proportionality theorem as the final reason for those ratios. So this is easy, guys. So obviously this question paper stops here. I don't know why. So there is the memo. You can explore it and see if I lied to you or not. But if you find that the memo is not making sense, then you can then look at what I did and hear my explanations, and perhaps you will have a clear understanding of what is going on. Either way, guys, I will cut it here. And I hope you've enjoyed the video. I will see you some other time. Goodbye.